Ladies and gentlemen, I'm Joseph Atick, Executive Chairman of ID for Africa, and I'm delighted to welcome you to LiveCast number 46. In this episode, we break new ground by exploring the impact of artificial intelligence on development. This is a hot topic that's evolving rapidly, and reliable information about it is elusive. This is why we curated this special episode to introduce our community to the transformative possibilities that AI offers. AI has already demonstrated its game-changing potential across a diverse array of industries and human pursuits. Early adopters in these domains are reporting three significant benefits. AI is driving substantial improvements in productivity, it is enabling a flood of innovation, and it is allowing for data-driven real-time decision-making. While it's true that there is an element of hype and irrational exuberance, it's clear that we've entered an era of hyper-innovation and rapid change driven by AI. We're witnessing a major disruptive force with far-reaching implications for humanity. So can ID4D and the broader development agenda afford to ignore this force? How can we harness its transformative potential? Can we identify and mitigate AI risks to ensure it can do no harm? These are some of the leading questions that we will explore in this extraordinary episode, which consists of three segments. In the first, we concentrate on the applications of large language models and generative AI as tools for development. We will examine not only the promise of AI integration, but also its potential technical pitfalls. In the second segment, we shift to a different aspect of AI use, namely its impact on biometric accuracy and trust. While strictly speaking, this is not generative AI, this application employs the same deep learning architecture encountered in segment one. Here we will see that virtually all leading biometric algorithms today are AI-driven. How did this massive transformation come about? And what implications does it hold for biometrics use in ID programs? And what can we expect next? These are some of the questions that our first presentation in segment two will expertly address. While the impact on biometric accuracy has been extremely positive, it comes at a price. AI has also facilitated the creation of new tools, such as deepfakes, which can be used to spoof biometric systems. In the absence of effective countermeasures, this poses a threat to the integrity of digital identity and can undermine its trustworthiness. Hence, in this segment, we also delve into available countermeasures to make ID systems resistant to AI-driven attacks. At ID for Africa, as always, we are committed to anchoring any conversation in the African context. In segment three, we will explore AI's potential to address Africa's immediate challenges and opportunities. As a development organization, we must also prioritize the examination of the equitable and ethical dimensions of AI, particularly the concern that it could widen the digital divide between developing and developed nations. The data revolution is upon us, and AI is making it abundantly clear that data poverty must be addressed alongside with real poverty. What are the barriers to entry into this new data-driven world? And what actions can Africa take to leverage AI to accelerate its development while minimizing disruptions to social safety nets that may arise as AI displaces certain livelihoods? Addressing these complex ethical questions is a challenging yet essential endeavor, which we initiate in segment three, even though definitive answers are not yet available. Our goal is to sensitize the development community to anticipate the inevitable impact of AI on Africa and the broader development agenda. So stay with us as we address the good, the bad, and the undefined of AI, featuring an exceptional lineup of some of the most brilliant minds in our community. But before we start this extraordinary episode, I have some important announcements to make. First, our next livecast, episode number 47, scheduled for February 28th, will be on the timely topic of digital identity and health. Earlier this week, we issued a call for speakers to make sure we source the latest experiences and most pertinent developments in this area. And we are in the process of curating that episode. So please hurry and submit your proposals before the December 8th deadline. The link is in the chat. In the meantime, I'd like to call your attention to another interesting digital health webinar featuring Ethiopia's Ministry of Health, organized by Simprints, taking place tomorrow. The link to the event is also in the chat. Second, let me update you on our 2024 AGM set for May 21st to 24 in the beautiful city of Cape Town under the theme of digital identity as DPI, fostering trust, inclusion, and adoption. Being the 10th anniversary of ID for Africa and the ID4D movement, we have extended this commemorative edition to 4 days instead of the customary 3. The 2024 AGM will include 12 plenary sessions with a tech and solutions expo over the first 3 days and 4 workshops and 4 forums on the 4th day, all structured as follows. On day 1, after the State of the ID4D address, we examine the latest progress in digital identity around the continent. Then we explore the strategic significance of the DPI approach to digital transformation. We then end the day with a lineup of compelling use cases for digital identity from Africa and beyond. On day 2, we start with the Technology and Solutions Symposium, which will showcase over a dozen successful digital identity and DPI projects. This will be followed by the eagerly anticipated NIST Biometric Performance Symposium. 3 of the world's foremost biometric experts from NIST, the organization renowned as the most trusted authority on biometric performance, will provide a comprehensive overview of their latest findings and will engage with our audience and our participants. To round off the day, we will examine various types of DPIs that have emerged, including digital payments, social protection, and health stacks that are integrated with identity and with civil registration platforms. On day 3, we start with another tour de force, delving into the 3 most important digital platforms for credential authentication and management: wallets, MDocs, and verifiable credentials. This session also explains how these innovations can seamlessly be integrated into conventional ID programs to arrive at robust digital ID verification frameworks for service delivery. Moving on, there will be 3 policy sessions back-to-back on safe, responsible, and inclusive identity programs. They are digital identity governance, digital identity and human rights, the civil society perspective, and finally, legal reforms for digital identity. These successive sessions will provide invaluable best practices and ample opportunities for inclusive dialogue. They delve into the guardrails, the enabling environment, and the societal and user considerations and legal requirements required for earning public trust. On day 4, we have 4 workshops and 4 forums. I will explain the workshops and the forums in more detail in the next livecast. Here, in the interest of time, I will only share the topics along with the sharing development partners. So in the morning, we have cybersecurity with the World Bank, a digital identity for refugees and displaced people by UNHCR, and the integration of CRVS with ID by UNICEF, and then an update on the African CRVS shared asset, AXA, by OpenCRVS. While in the afternoon, we will have a workshop on ID system procurement by UNDP, and another workshop on DPI and DPG interoperability and collaboration by GovStack and OpenG2P. We will also have a forum on data protection in Africa by NADPA, the Network of African Data Protection Authorities. And finally, we will have the academic institution WISER for social and economic research, talking to us about the engineering of trust, and a thought-provoking session about whether we can engineer trust. Okay, So, as I mentioned earlier, over the first 3 days, we will have a significant presence of technical and solutions expertise within the networking and expo zone. Here are the logos of who will be there. I would also like to acknowledge and thank the development partners and the patrons of the 2024 AGM. Moving on to our African government attendees, I'd like to inform you that the ambassador bureaus in the 48 member countries are already forming their official delegates, with the process set to conclude by December 15. We encourage you to promptly reach out to your country's ID for Africa Bureau to explore the possibility of your organization being represented within the official delegation. If your organization is not selected due to limited quotas, rest assured you can still make independent arrangements to attend. Just register early while space lasts, as we have a limit of 2,000 attendees, including official African government delegations, private sector, and development agencies from all over the world. Registration for all participants will open in January, and seats will be allocated on a first-come, first-served basis. In closing, expect the 2024 AGM to be a thrilling journey that thoughtfully addresses the current ID4D agenda and brings it into the digital age. To build the program, we're meticulously sourcing relevant content, curating it into trustworthy knowledge that we will disseminate throughout the AGM sessions to stimulate actionable dialogue. We truly hope you will be able to join us to experience the tradition that reinvents itself every year with new innovations and a highly responsive agenda. We're now ready to start this episode. I'd like to welcome, in the order of appearance, Parankusha Seshadri, Director of Technology Consulting, Ernst & Young. Benjamin Bertelsen, Product Specialist, UNDP. Professor Carsten Maple, Professor of Cyber Systems Engineering, University of Warwick. Dr. Stephane Gentric, Chief AI Scientist, IDEMIA. Professor Stephanie Schuckers, Professor of Engineering Science, Clarkson University. Francis Zelazny, CEO, Anonybit. Dr. Melissa Omino, Director, Center for Intellectual Property and Information Technology Law, CIPIT. Dr. Angeline Wairegi, Interim Research Manager, CIPIT. And Govind Shuvkumar, Director of Responsible Technology, Omidyar Network. Warm welcome and sincere thank you to all the panelists for being with us. We truly appreciate your valuable contributions to this livecast and to the cause of responsible identity for all. I look forward to engaging with each of you within the different segments. We're now ready to start the first segment. So operator, prepare the panel. We will start with a fascinating presentation from Parankusha Seshadri from Ernst & Young. Parankusha, welcome once again. Thank you for being with us. I will relinquish the floor to you.
Thank you very much, Dr. Atick. Also, thanks again for this opportunity to you and to the entire ID for Africa team. So truly a privilege to be sharing this discussion with such experts on the panel on this not only very interesting topic, but something that is extremely important, like you already mentioned, Dr. Atick. So let me just share my screen and get going with the presentation. All right. So this is how I'll be structuring my talk. Many of you already know what generative AI is. So nevertheless, I'll just give a very quick introduction to it, maybe stressing on few items that many would not know. I will also then follow that up with what is the need for capacity building in ID solution implementation and the entire ID ecosystem, and not just foundational ID, but social protection, payments, and so on. Right? And how AI, and more specifically generative AI, how can that address this capacity building requirement? I'll be showcasing few use cases with examples, and we'll also follow that up with a demonstration of a few of these use cases that we can easily relate to. All right. So before I start off, I just want to have a disclaimer here. In my presentation and in the demo, there'll be a lot of references to OpenAI, but that doesn't mean that there is any subjective bias to OpenAI. It is just that, it is so ubiquitous right now, and it is easier for all of us to relate to what Gen AI, what GPT or Chat GPT, and what OpenAI has brought to the table. So it is only with respect to how easy it is for us to relate to the various topics and demonstrations. Okay, so what is Gen AI and what is this GPT that we are all now hearing in a very big way? GPT stands for Generative Pre-trained Transformer. Okay, I'll go into the details, but before that, I just want to bring your attention to the bottom right side of the screen where I'm talking about model size here. Just a little bit of history here. This entire AI revolution with respect to deep learning started off somewhere around 2012, 2013-ish. At that time, the brain or the model size was around just a GB. That could easily fit on anybody's laptop. You could train such deep learning modules on easy infrastructure. Fast forward to 2023, now we have these large language models and generative AI models that are close to a TB worth of memory usage within graphical processing units. Not to go into the technical details of it, but what I want to just impress upon here is that these models have become very complex and extremely powerful. And that is the reason why the pre-trained as to what is mentioned here becomes so critical. These models have truly become, or at least moving towards, what everybody is striving towards is the artificial general intelligence. Now, another point that I want to truly mention out here is on the generative part. So pre-trained, I've covered that. These are models that you can readily use without having to train anything further. And it is generative because it can predict the next sequence of characters or the next sequence of pixels with extremely high levels of accuracy. What that means is that these models are now able to really understand what the context is and what the data has been provided to them, what prompts were feeding into it. Right. So this, in a nutshell, is what GPT is and is what is driving, generative AI revolution. So coming to large language models, very specifically to how we process text itself within the generative AI space. Right. So there are two dimensions to it. One is what is the input. The second one is what are the capabilities of these LLMs. Right. On the input side, again, just to stress on the pre-trained dimension of it, is that you have the global setting, right? The large language models are already pre-trained, but then when we interact with them, there are various parameters that we can configure. We can tell it to hallucinate a bit less by setting various temperature parameters, for example, or we can allow it to be a bit more imaginative when we have to, depending on the use case, depending on our requirement, right? And everything is driven by various prompts. The new language of coding, in fact, is going to be English and natural language, right? So prompt engineering has gained a lot of traction, because of this and because of the large language models and the way they function, right? On the other side, we all have our own private data that we need to leverage. It is just not enough as to what ChatGPT or OpenAI or Google Bard, what they bring to the table. We have our own documentation, we have our source code, we have our user manuals. All of that has to be ingested into a generative AI system. So for that, the technical term that is used is RAG. It's retrieval augmented generation. Not to get too technical, but the fact is that there is a mechanism by which you can take in the content from your personal data, ingest it into the LLM, and then allow it to do a lot of wonderful things that you see on the right side. You can use generative AI to summarize text, to have a chat kind of an interface. And more importantly, for capacity building, we can allow it to become a knowledge engine where we can ask questions, get answers, allow it to behave as an expert system, and for engineers and developers, of course, use that as a very powerful code generation tool and a utility and a partner. So this is the promise of what LLM is. From the last 1 year, we have seen that there's a lot of traction that has gone into it. So before I go into the use cases part, right? Very quickly, I just want to highlight as to what I mean by retrieval augmented generation. Right. So there are two parts to it. One is the offline part, which you see at the bottom of the screen. Imagine that you have various DPGs, right? All the popular ones, MOSIP, OpenCRVS, OpenG2P, and many others. You have them. Can we create a powerful engine that leverages all the documentation that is there within them, the source code that is there within them, the community forums that they have built, and then help us to become a lot more productive, right? So using this RAG technique, one can take up all of this and combine them and then segregate them into various use cases. You want them to create a knowledge engine using the documentation, go ahead and create a vector store for that. You want to create an L1 support, L2 support engine, then take all the community forum queries and convert that into a vector store. Similarly, you want to create integration code whereby you are making all these DPGs are already interoperable, and you have to create some glue code, for example. Then you can take the source code and create a vector store out of it, and then feed that into a popular LLM, be it GPT-4, which is the most powerful one that we see now, and then allow that to create content that we can truly use to become a lot more productive. So again, just to summarize, as developers so far, to be very productive, we adopt various best practices. Pair programming has been truly popular when it comes to extreme programming. And this is the, I would say, state of the art when it comes to the process as of now, right? Using generative AI, pair programming is transformed. Each and every developer who has that kind of experience in the domain, I wouldn't say a beginner, but a developer who has that relevant experience can truly become a superhero developer. And we see this generative AI being integrated across different tools in the SDLC lifecycle, be it with integrated development environments, IDEs or code editors, or even with respect to the DevOps. And what we see with GitHub, in fact, GitHub introducing the GitHub Copilot, where every developer has access to a lot of generative AI tools, not just for generating code, but also to test them and also to do some kind of security validation and so on and so forth. And this is the promise that generative AI has brought into foray right now. So moving on to ID specifically, I will not be talking about the pitfalls of LLM. I'll just be talking about the positives and what can be done, what can be achieved, and how we can address it. So if you look at the ID solution, entire ecosystem, right, the adoption of it is plagued with various challenges, right? It has to operate at population scale, and it is very complex, right? You need to have expert architects across various domains to be present right now, not just on enterprise architecture, but even on security architecture, data architecture, and even the business architecture side. Having the knowledge engine, like the way we just understood now, can truly help, augmenting the team to address this. Data security and privacy is one of the biggest challenges. The promise of Gen AI is that you can do the same or a lot more, or be even 10x productive with your current team. That means that you have fewer people, in the team, which means that fewer people have access to PII, and to a large extent, it kind of addresses various challenges. User education and adoption has always been a big challenge. L1, L2 support, whenever it is possible on demand, to get it from various open source platforms is difficult. You need to have a large team to do that. Generative AI can truly tackle this. I'll just draw your attention to another last dimension of this, not just the technical challenges, but also something on the financial and political challenges. Time to market is very key. Now, when you talk about political considerations, the way stakeholders do change within the ecosystem out here, whatever has been promised and then agreed upon, when the stakeholders change, then it becomes very difficult, to go back and implement it or re-implement the solution with different targets. So time to market is very key. If that has been shortened, then you can meet a lot of requirements based on whatever commitments have been made. So coming to the use cases based on the benefits, right? Very clearly, Gen AI, as we see within the ID space, can help in L1 support, right? Instead of waiting for a couple of days for a particular response on a simple query, you can get that on demand. Create a lot of knowledge oracles, a lot of knowledge engines, so that people can get up to speed with any platform very quickly without having to wait for an expert to come and impart that knowledge. Code generation, like we spoke about, for sure is going to be a big boost. In fact, when the Gen AI or when the LLM story started, it started off with saying that they are going to revolutionize software 2.0, which was basically generation of code. Combine this with DevOps, you get an integrated SDLC story that can truly augment and boost the productivity of the entire team. Few other use cases, which I will not be covering as examples, but very important to just know about. Social media monitoring is very key when it comes to ID solutions, because everything is built on trust, and trust also depends on perception. A lot of news on various systems can be tracked and monitored effectively by using generative AI. This was also done previously, but because Gen AI solutions can truly understand the content, be it in text or be it in images, it will truly prove to be a very important technology that can be leveraged. Combine this with visual intelligence, you can also have very powerful fraud detection systems installed at various enrollment centers, which otherwise would have not been caught, especially when you're talking about massive population scale operations, very difficult to track each and everything without having an automated system in place. Okay, so what I'll do now is that I will give an example of this and also back it up by a demonstration, so that it's not just all theory that many of us would know about. We can also see something in action. So Dr. Atick, I hope that is okay with you, so that I can switch between the example and the...
Yes, please, go ahead.
All right, thank you. Okay. So first example is L1 support. Many a times the queries that you get on a system would be just somebody would be only seeking for some kind of information, or it would be a trivial problem if addressed at the right time, would save a lot of time and effort. However, we see that even such simple queries, it takes around a couple of days for the team to respond to, just only because you do not have enough people on the team supporting this. Let me give a simple example out here. I'll just give the demo out here. So again, thanks to the collaboration with the MOSIP team, we have something very tangible to show here. Although there would be a formal announcement through the MOSIP team, I am here only to showcase what is possible and the capabilities of the Gen AI, taking MOSIP as an example, and it can be adopted to any DPG or any solution or any system that has enough documentation and good amount of source code to work with. So just a simple question. Many from the MOSIP world would know that I'm facing an issue in configuring a particular module. How do I proceed? And so on and so forth, right? And usually these things would, for somebody who knows about it, it would be as simple as pointing them to the right direction and saying that, look, you just need to make these changes, make you need to check if a particular module is up and running, and so on. In the interest of time, this is a live demo, but when you get the response, this corresponds to something with Kubernetes, with how it has been deployed, and the MOSIP GPT that has been trained on this comes up with the response giving step-by-step procedure as to what has to be verified, and at the end, what kind of status has to be checked, and so on. And then it will help the developer or anybody who's seeking this information to get past that particular query. And another kind of use case is when you have just started off with a particular system, and you would like to know, what do I need to do next? For example, in MOSIP, if I need to perform a language customization, how do I do? What kind of configuration file do I need to change? So if I do ask such a question to MOSIP GPT, how do I go about language customizations for the resident module? I get all the step-by-step, the steps that need to be followed, and also the various configuration or the parameters that need to be changed, and how to go about it, right? So although this kind of trivializes how things can be tackled from a usability point of view, but it also showcases the power that, using this, we become very productive in nature. Couple of years from now, we may not even be worrying about such kind of L1 support or delays in support kind of issues. What about, code generation? Earlier with generative AI, all we could think about is boilerplate code generation, right? Just so that somebody can get started with coding. But now with something that is as powerful as GPT-4, it not only generates the boilerplate code and the glue code to integrate systems, but a lot of meat within this code itself. A lot of logic that we'll have to hand code right now can be automatically generated. I'll just show an example of that as well. Let me do some live demonstration. Hope that it comes out quickly in the interest of time here. So I'm just saying that I need to perform a demographic-based deduplication. Can you provide a Java code to do this within the context of MOSIP? Right. So the system should not only know that it has to generate some code based on age, gender, address, but also make it very contextual, very specific to what MOSIP has to provide. As we know that MOSIP has various modules within it, right? I'm just hoping that it comes up within the time frame. And this is running completely on the OpenAI platform directly. So let's just give it a minute. And in the meantime, I'll also just see if I do have a particular thing already pre-generated so that we can go through that. Okay, great. So we have it. Okay. Okay, so it has generated it. So it does provide the kind of customization that is required for duplication, generates the Java code with the documentation as well. And as an example, it does also give us the link to in what kind of documentation within Mosaic you can go ahead and make those changes as well. You can, of course, go on and interact with it and make further changes to the code and not just use the boilerplate code as is. As a last demonstration, I would like to show that one can integrate the entire generative AI story with not just in a piecemeal manner, but create a holistic integrated DevOps journey as well. We saw that we can create various knowledge oracles, extract information, understand the system. Second, we saw that it can generate code. It can also generate deployment scripts, create on Kubernetes, Docker-based systems, generate those scripts. And thirdly, can also integrate that with powerful CI/CD systems from Jenkins and from GitLab and so on. With this, you can leverage the power of generative AI that is running on a separate infrastructure, integrate that with your infrastructure where your systems are running without having to worry about the heavy GPU infra that is needed to run these powerful AI systems. And let me just try to give an example of this as well. So this has been specifically trained on Mosaic documentation. And with the latest GPT-4 that is available, you can create your own personal GPTs. So I'll just go ahead and ask it that I need to customize my registration client. I need to customize my reg client. And then I'm asking it, what config files do I need to go ahead and edit? So this GPT now is supposed to go through all of the documentation that is available, Mosaic, the latest one, 1.2.0, and come back saying that these are the configuration files that are there, and this is the parameter that you need to edit in them. Hopefully, it should just take a few more seconds. I really appreciate everybody's patience here, given that it's a live demo. All right. Okay, so just to summarize here, I would have shown a few more steps, but in the interest of time, I'll just quickly summarize that generative AI is truly powerful. We can now not only generate code, integrate with your systems, and the point that I wanted to highlight in this last particular piece of demo is that although the infrastructure needed for generative AI is on the higher side, we don't have to worry about it because you have all the tools from various offerings, various providers, from Google, from Microsoft Azure, so on, where you can clearly separate out your infrastructure for your platform and not worry about the generative AI infrastructure. And leveraging that will truly help in providing that much needed boost to productivity and capacity building. All right, thank you.
Excellent. Thank you for this fascinating presentation, Parankusha. I wanted to ask you, basically, clearly, we want to see this type of tool in the hands of developers and countries that have low capacity, so that we can accelerate the development. Do you think this is realistic to expect that instead of being trained to write other language, Java or C++ code or whatever, that they can actually write using normal prompts? I mean, you've been showing us prompts and it's been generating native code. Can you explain what does a country need to do in order to prepare its developer team to take advantage of such a tool?
Right, absolutely. So the way we are seeing is that any developer or even a business analyst who is well aware of what has to be done is now equipped with converting the what part into how to implement it.
How?
So the new language of development now has become English or natural language, or it could be any other language that can be converted into English for now, and then that gets converted into the code that is needed. So, so again, the point here is that development and capacity boosting with respect to engineering teams can truly be achieved by having a smaller team that has the know-how and that can translate that know-how into the actual implementing or actual working product. So that is truly possible with respect to the advancements that we're seeing in the Gen AI space.
But what extra training does that team need? I mean, you seem to be aware of how to use the prompts. So prompt engineering, is this something that is easy to learn, or there is a barrier learning curve?
The barriers out here are very low. Of course, the team has to be aware of some kind of coding techniques. The team is aware of Python, Java, or any other language that is used in these DPGs. That awareness is good enough. But where we see that people kind of struggle or development teams struggle is with respect to writing complex code and integrating that in a large system. So such kind of complexities can be now abstracted out, allow Gen AI to do the heavy lifting, and some kind of only validation or proofreading is what is required by the teams right now to take it forward.
Now, obviously, everybody knows how they can get access to ChatGPT, and they can log in, create an account with OpenAI or with Bard, etc. You've showed us a customized version. This is not a foundational model. This is a more digital identity specific model. Will that model be available for the community, or will this be hosted? Each country will host its own in the national ID program, etc. How will people have access to the work that you have done to customize and to localize it into an accessible tool like a chat?
Right. It should be available. We should be able to make it available for everybody to use it. But there is one trend that we are observing with respect to how these generative AI models are evolving is that the need for a platform play between the generative AI solution and the actual solution implementation is kind of going away. All the complexities of Gen AI is getting taken care of by the Gen AI providers themselves, that is, be it OpenAI or Google. So the entire chat solution would be hosted on OpenAI or Azure or Google. And then only the integration will have to be done with respect to your own development environment or production environment. So the brain of the chat or the knowledge oracle, so to speak, would be provisioned by OpenAI or other Gen AI providers.
Right. And so, but as a consequence, do people need to have an account with OpenAI or Bard, or will they do it in a manner that basically allows free and open in the spirit of the open source movement, DPGs?
Yeah, that's a very good point, Dr. Atick. So there are many open source models or Gen AI solutions available as well. So a lot of permutations and combinations are for sure possible depending on data security and other requirements. State of the art right now is, unfortunately, it is not within the open source space. It is within these proprietary models. So to fully leverage the power of Gen AI, we kind of now gravitate towards what is being offered by these big companies. However, in the future, for sure, the open source models would also become as powerful as them, and then address this and foster this open source and DPG kind of movement that we are seeing in the ID space.
Okay, so your predictions in terms of the impact on real ID development in Africa and other developing contexts over the next 3 years, what do you think this is going to look like?
I think it truly boils down to now the our willpower as to our intent and intentions, and as to how far we can go with this. A lot of conviction is required. Technology is for sure out there as an enabler to do this. But then if we can get the implementation story right in leveraging this, then for sure, capacity building will not be a problem within the ID space as we speak. And all of this is again, thanks to such a wonderful community and such wonderful DPGs that we do have already in the system that is kind of fostering and taking this movement forward.
We've run out of time, Parankusha. There is a question about the equitability, transparency, and trustworthiness. We'll try to address these ethical issues at the end in general, because this is not specific to this issue. It does raise the question whether basically this is a wonderful development, but maybe it won't be available just because of the way it's controlled and the sovereignty aspect of it, etc. So we'll address that in another segment at the end, hopefully. If not, we will have another opportunity in the future to track your progress in this fascinating field. So Parankusha, thank you so much. We've ran out of time. We'd have loved to have you more.
Thank you so much.
Thank you. Thank you. Okay, actually, we want to continue. I want to do a couple of in-conversation pieces. I want to start by bringing Benjamin Bertelsen from UNDP. I want to welcome Ben and thank you. Well, thank you again for being with us. Just I want to remind the audience that in the last LiveCast episode, we presented the UNDP Digital Identity Governance Framework, an important and timely development. And during that presentation, it was mentioned that there is a large language model-based knowledge system or an expert system that was incorporated into the framework tool available online. So I'd like to start by asking you, Ben, how have large language models contributed to the UNDP governance framework?
Yeah, absolutely. Let me start by saying thank you, Dr. Atick, and to the ID for Africa team for having me on here on the session, and thank you all for tuning into this. I'm dialing in today from the Digital Public Goods Alliance annual meeting. So from one great platform to another one here, it's a pleasure to be on today. As you were saying, the chatbots, the open language model chatbot we've developed for this is a small part of the governance framework that we released at the UN General Assembly back in September, and we're offering out to make it easier to navigate the many difficult governance questions. The way that we've used the chatbot is during the process of generating this framework, we came across more than 80 toolkits, guides, briefs, playbooks, reports, all circling around the questions of good governance for digital ID. And we thought, how can we make it easier for colleagues and partners to search out in these questions? And we thought that a chatbot might be a good way for people to interact with. So that's how the idea came up, and we integrated it on the website that my colleague Risa has shared in the chat.
So it's basically a knowledge system that instead of us having to go through 80 to 100 different documents, you were able to load, and we'll talk about that in a second, you were able to load these source documents into this expert knowledge system. And basically at that point in time, that knowledge system is available in a dynamic way. You can ask it to generate dynamic content and respond to any questions.
Yes.
Would that be a fair characterization?
That's a fair characterization. I'm happy also to demo here if you're interested.
Yes, we're going to do that in a second. But actually, can you explain the steps? I kind of alluded to them, but perhaps you can explain the steps that you've taken and what was involved and how much control you had on the learning process, etc.
Yeah, sure, absolutely. And Parankusha's good presentation has a really good lead up to this. There was a slide previously that talked about the retrieval augmented generation or the retrieval augmented response. And this is really the technique that we use here. So we take the 80 documents that we have and the framework we've generated, the UNDP model governance framework, and we feed that into a system. And what happens is that when the user asks a question, we go in and we do what we call a semantic search in that system to find out what's closest in all this text we've gathered, what is the closest elements there, and then we send that with the question to ChatGPT, and that formulates a response back to the user in the chat window. So what's different about this is that's what we call semantic search. So we're searching here in meaning as opposed to keyword search. Whereas if you open the PDF and you search for governance, you get 100 different ones. That's keyword search. So here we're searching semantically.
And how long did it take for you to load these 80 documents into your expert system?
Yeah, I mean, what took time in this process was the entire searching out all the reports and frameworks, right, and vetting them. And we had an expert panel of 25 people come in over and discuss these various elements and get our framework put together. So that was really the time-intensive part of this project. The development of the chatbot itself, I mean, there are so many good tools and frameworks out there now, and we have a team within the UNDP that has done other AI projects for other things. We have a data topology navigator as well, where we have a similar tool. It took them probably about a week, I'd say maybe 5 days or 4 days to get this up and running.
Wow.
To a few of the steps in this, Dr. Atick. It's of course loading it. It's doing something, a temperature setting, which is essentially how random do we want the chatbot to be? How alive do we want it to be? And it goes between 0 and 1, where 0, it's very deterministic because these are probabilistic systems, right? And 1, then it can kind of free flow and be very like alive. And I think we've set it to like 0.1 or something because we do not want it to be too to give you some, which is not true. Yeah.
Yeah. So, but the human element was in the building of the data sets. You didn't take random. You had to validate that these were good frameworks that we could learn from, etc. Would that be correct to say?
Yeah, so we've a good practice for developing this is prioritizing quality over quantity of content put in. So we try to do that.
Quality over quantity, and you're actually whetting my appetite. I'm thinking about another big problem that we have in Africa, for example, which is the need to harmonize legal frameworks related to digital identity and civil registration. We've got, I would say, 100 documents in that regard, or more. Would you see that amenable to this type of analysis?
I mean, absolutely. If we can get a hold of the legal frameworks, and I presume most of them are publicly available.
Right, they are publicly available.
OCR analysis on them, but that's also possible, and then we could feed them. And we have been talking about and discussing the opportunity of doing some analysis across country through the legal frameworks for ID.
We would love to sort of drive a call for action and a collaboration across the continent, a collaboration with the UNDP, of course, and other agencies, development agencies, because there is a real need to get coherence. Last year, we had a workshop on legal frameworks, and we saw that there were sort of lots of different gaps and there are lots of overlaps, but there's no single human is able to get an overview of where the legal frameworks are, the gaps, the fillings, what are the experiences, etc. So maybe if any of the development agencies that are listening, any of the donors and funding agencies are listening, we would love to push for such a project. Actually, let me ask you, you offered to do a demo for us, right? Would you be willing to show us a real-time demo? Even though you are from not in headquarters, you're on the road.
I'll be happy to. I hope the connection holds up here while
please.
I'm on screen. Is it visible on your end now?
Yes, we can see it.
Wonderful. Wonderful. So this is the website for the governance framework, and I'm not going to go into the framework itself, but instead call attention to the gateway here to the chatbot. And so here it opens our chatbot, and I had another prompt planned for this, but now Dr. Atick, you mentioned your next section is going to be on ID and health. So maybe we
Yes.
can primer for that and ask, why is digital ID important for health care provision?
Okay.
And let's see what
See what it comes up with.
It's a little teaser for next section. Next
Oh,
session.
wonderful. I can't wait. Okay. Okay. It's putting up some really detailed response.
It's putting up some fairly detailed reports. Let's see.
Right. Is it sensible?
Rapidly increasing healthcare coverage.
Can be used to identify individuals who are not yet covered. Okay.
Yeah.
Easier verification.
Reference verification from Thailand. Easier verification. Yeah.
Efficient delivery of healthcare programs.
I'd say
online
that's fair as well.
Right.
Service. Efficient rollout. And then there's a COVID-19 case. You can discuss the relevancy of that, but fair. Right. And then it also does a reference in the end to a World Bank report of on this. So overall, a fairly helpful response, I'd say, if you just want a general overview of some cases. I can try one as well that I know where, like, this is a good case. Like, it's good at summarizing like some knowledge it already has. If I can be self-critical for this chat, but maybe show a case of where it struggles more just to align expectations, that would be, say, what is the most recent development in, let's say, Malawi's digital identity system? And now, yeah, I'm sorry, but I couldn't find any specific information regarding that, because most likely because the sources here, they don't have that most recent information on that. Whereas I have a lot happening in Malawi, in fact. But yes,
there's a training cutoff. Ask it specific questions about governance, for example. What are the top 5 things for good governance of digital ID? Top 5 practices or top elements, required for digital governance, for good governance of digital ID. Digital ID. Okay, let's see what that wisdom comes up with. Okay, inclusion, accessibility, privacy and data protection, interoperability, legal and regulatory, financial and operational sustainability. Okay, I think, to be honest with you, it's quite sensible that it identified inclusion as the number one, which is a principle that we all subscribe to. Privacy and data protection. Bravo, that's fantastic. What do you think?
I think these are good. I mean, as UNDP and as everyone here on the call, I think we would all prescribe exactly as you're saying, to inclusion, accessibility, privacy as data protection. These are indeed some of the tricky questions. Who protects my data? Who handles my data when we set up ID systems?
Now, when people come to the UNDP chatbot, and they pose this question, you parse this question and you pass it through ChatGPT and then bring it back, or what is the engine behind this? Can you describe that process?
Yeah, so technically what happens in the back is that as soon as you've provided a question to it, we take that question and we take every word in that question and we make that into a mathematical string, a token.
Right.
Then we take that and that becomes kind of like a weird multidimensional shape, that question. And then if you imagine the entire text we have in the back, that's also a series of many, many weird shapes we can't even imagine. And these shapes, they kind of match up against each other. And those shapes we then take and we take them away from the tokens, away from the numbers, down to text again, and feed that to ChatGPT. And then ChatGPT returns with a response. So that's what's happens in the back with this.
So, but ultimately, it is ChatGPT that's that you're using as the large language model behind, but you're interfacing with it. Do you filter at all when the answer comes back? Are there filters to monitor, make sure it's not hallucinating and giving answers? How do you do that?
We have done some pre-prompting to it. So there are certain things where we have instructed it to like be aware that you're developed by the UNDP, be careful about certain things, don't advise about ill practices around ID. So we've kind of safeguarded it in certain ways in its responses. We are considering to have a second check of the responses that it's providing. So UNDP has a lot of other digital guidelines for doing good digital practice implementation. So you can imagine when we get the response from ChatGPT, we can put it through another filter of like, does this response still live up to some of our other good requirements? And then you should give the response to the user.
Right.
We're still in a beta testing phase with it. So at the moment, we haven't felt the need to implement that filter, but we'll need to check more and see what kind of comes out. And then maybe we'll implement that filter too.
Would you imagine, for example, a crowdsourced participation, for example, where you would tell the community, you'd say, please challenge the system. And if there is an answer that you are in disagreement with because you think it violates ethical or violates good practices, let us know and let's have a debate. I mean, debating the ChatGPT with the community. I mean, in a way, you would get a lot of people asking it questions, and then you end up testing it, no?
That's a really interesting point. I'd say we are the UNDP model governance framework for digital ID. We are in a process of open sourcing the entire framework. So
Open sourcing it.
we found a good platform for open sourcing that where people, they can access the framework and they can suggest updates to the framework. Governance questions to ask, sources, scenarios, risks, and send those requests for changes, just as you would request a change for code if you're a developer. And we would look through those proposed changes, and then we would merge them in if we like them into the framework, and if our advisory board they like them. So we have to design a process for that, but we're in the process of that. So that's kind of an open sourcing and kind of improving something. It's not quite to the level that you're alluding to with the chatbot, but I'll have to talk to the development team and figure out if there's a way to do that in a smart way.
So what would you say in the last minute that we have, what would you say is the future of consultants in this business? Has ChatGPT kind of threatened the consultants in the sense if ChatGPT becomes a super consultant, ask it any question, it comes back with a beautiful answer. What are the consultants going to do?
You, Dr. Atick, you're talking to a former consultant here. So I hope this provides a better starting point for people to ask the consultants tougher questions and to have better terms of reference for the consultants. Maybe it's a starting point that's important to say. And in terms of what's next, otherwise, we've hired a project manager for this project, and we're hiring a governance consultant, and we're in conversations with multiple countries around rolling out the governance framework, helping assess governance using this. We're having some ideas around giving users the options to identify themselves with a name and contact information and organization, and asking, is it okay that we record your responses? Because we don't do that now. We don't keep this data. But if we could keep it, it will give us some really interesting insights into what kind of governance questions do people have. And can we link that into digital ID projects we're doing around in the UNDP based on our evaluations reports and project reports, so we can begin to link countries to one another and say, hey, what you're asking about is actually work we've done in Honduras or Zimbabwe or Malawi. So in that way, start to connect people through this tool.
That's phenomenal. In any case, I think we're raising the bar. Raising the bar, and that the starting point is not at the bottom. The starting point is midway somewhere here, and that we all have to add value because knowledge is now available and in a package that's dynamic. So fantastic, really fantastic. Thank you for taking the time to be with us. I know you're busy at the DPG conference, so once again, accept our sincere thank you, and we hope to see you again in the future.
Thank you.
Thank you, Ben. We'll continue with another in conversation piece. I'm pleased to have with us today Professor Carsten Maple, from Turing Institute and from Warwick University, to share with us his insights on this topic. Carsten, good to have you with us, and thanks for taking the time. You and your students and colleagues actually have been doing a lot of research on AI and large language models and its impact in many practical domains. I want to give you the opportunity to take us at a high level, so from a bird's eye view, and walk us through what is the true potential of LLMs for digital identity system development. Assess for us the promise of those developments.
Thank you, Dr. Atick, and it's a pleasure to be here. Yeah, we've just heard two excellent presentations on some of the specific use cases and seen some examples, and I'll give you some of the ideas where we've seen some of the promise that we can see, and it will really put this high-level view, as you said, onto what we've seen in some detail. So we really see that LLMs largely used, as we've seen, for textual analysis, but of course there are multimodal LLMs that give more opportunities. But one of the first cases that we see is LLMs for insight generation. So if you were developing a solution for a digital ID system, so anything like that is a multi-partner ecosystem, you need to take input from a number of different partners, including governments, NGOs, private sector partners, civil society. And that information comes in multiple formats. It may be structured or less structured. In the case of structured, you'd have reports, data, standards, guidelines. And LLMs have got a great capability to capture that information from multiple documents and present it in a way to whoever the user is. People will have seen that one of the ways that people bypass guardrails earlier was in ChatGPT was, tell me as if I'm an 8-year-old, right? One can create a persona, and I think we heard Benjamin say something around this, in a sense, saying to the LLM that this is the UNDP creating this and they have obligations. So using that, you can create this insight for different types of people with different backgrounds, and we see that as important. We also see that it's possible to understand the potential conflicts before field-wide implementation, and this is particularly with the use of unstructured data. So you can gain perspectives from different parts of society, either civil groups, as I mentioned before, or individuals, to understand what it means to integrate field-wide implementation of digital ID. You've touched on yourself, you mentioned about the legislative regulations. There are limitations within legislative regulations governing identity systems. Existing laws and regulations might fail to adequately cover all relevant issues, leaving gaps or ambiguities. And this can hinder the effective implementation and operation of digital ID systems. So large language models can translate and structure this knowledge to enhance the lawmaking process by presenting an analysis of different laws across different nations, especially if we're looking for interoperability. One of the top elements when you asked that question of Benjamin for the chatbots from UNDP was around inclusivity. And one of the things is that we think LLMs can be used for inclusivity of the registration and authentication process. If you've got people with either some form of disability or lower level of reading capability, different languages, then what can happen is that LLMs in low resource languages can increase the accessibility of identity registration and authentication by offering multimodal remote support. The fifth element is accelerating the digitalization of physical records. So you heard Benjamin talk about optical character recognition, OCR, he mentioned. One of the things is that we still have identification systems that rely on physical centers for registration and maintenance of ID records. And it's possible that in remote or unserved areas, multimodal LLMs can increase the speed of digitalization, thereby minimizing human assistance. And finally, if we look back at the sort of co-pilot approaches that we heard by Parankusha, where you're generating code, throughout all the steps of the ID lifecycle, there are opportunities to support the implementation. And code generation is one of those that's used. As I said, at the moment, there are tools from GitHub like Copilot and others, but what's really important around this is effective human-machine teaming. It's a term that hopefully more people are hearing, but how do we integrate humans in these AI systems?
So, Carsten, you've given us 5 or 6 real use cases. Do I gather you are a believer, a skeptic, or on the fence?
You know, I think LLMs can have a really significant effect. We should be aware that these large language models have been around for a long time. I think we saw with Parankusha about the development from some of the early number of parameters to where we are now, and they certainly seem impressive. OpenAI really opened their technology to the public. So people thought, wow, there's lots of things we can do. And it is impressive, but there are some things we have to be careful about.
Right, we'll talk about the pitfalls. We'll talk about the pitfalls in a second, but I wanted to know sort of your gut feeling, whether you think this is going to be a boost to the development agenda or not.
I think it definitely will, so long as we use it carefully. Okay. Definitely
so then let's take the other side of the coin. What do you see at a high level, the risks and pitfalls that might emerge from integration of AI and large language models with the digital identity development agenda?
Yeah, and these are things we've just got to consider and manage, and some are more manageable than others. Some need more work. But I think one of the things is bias and fairness. So we talk about the inclusivity of a digital ID system, but actually these tools can have bias integrated into them. As you've heard, they take a large corpus of information, and that information is different for different LLMs. A lot of talk about ChatGPT, of course, but there are other large language models that can be used. But the thing is, if that data that starts at the beginning is biased, then there is a problem that will propagate into the system. So bias and fairness is one of the most important things we think, because inclusivity is so important at the top.
Right, but do you think bias and fairness is a reflection of what already exists in society? Because the ChatGPT did not invent it, it just reflected it, isn't it?
Yes, but we shouldn't propagate that, right? We should be trying to reduce that, and we have an opportunity to reduce that if we do it in the right way. And it was great to hear Benjamin saying about some of those guardrails that they were introducing to make sure. But the other thing is, you'll have heard the term, and I think you may have used it yourself, hallucinations. I've been talking about one of these challenges with some of the large language models for quite some time. And I think it's more than hallucination. So a hallucination is something we believe is real. So the model returns something. It's very convincing.
Yeah.
Now, the problem is it's not always just a hallucination. The problem is it gives a convincing answer because it's got a user element towards it. But the problem is sometimes it's just not confident. It may be right, but it's not confident in what it says. So actually, if you challenge it, sometimes it will say, oh, you're right, I apologize. And it was actually right all the time. So you've got to weigh up a little bit more than just hallucinations, but we must be aware of those. We have to understand that we don't quite know how to evaluate the efficacy and truthfulness and confidence of these LLMs yet. And that's a barrier that we need to think about that we haven't got effective tools or frameworks to do that just yet. Of course, when you have lots of data that's being trained, there are concerns around privacy. So there can be privacy of information that's used in the training. And that it does include personal information. So we talk about that, but it could be about commercial sensitive. If something's out on the internet, should it be used in a large language model in the corpus? And that's been some challenge, and there's some legal challenges going on at the moment. But also, if the information that you feed in then is used for later training, that also creates a problem. You mentioned yourself knowledge cutoff. You mentioned so this is something that's quite important, because, of course, it's trained at a certain point of time, and there's a reason for that, because you don't want it to be manipulated. So the knowledge cutoff, we saw Benjamin challenge their own chatbot.
Malawi.
There's a computational power issue, of course. It's very well reported about OpenAI's model and how much it costs per query. So it's a number of cents using US currency for each query, but there's the whole architecture behind that. And of course, ChatGPT is just one of many.
Yeah.
So we have to think about that cost. Do we have in the future where people, certainly in the UK, talk about Googling something? We've got one large search engine that does a lot of the work. And do we end up with a sort of oligopoly or a monopoly in terms of one provider, which can cause all kinds of secondary issues? We don't understand fully the attack vectors for these LLMs. As they become more important to the identity system and people are using them and relying on them, can we manipulate them in a way so that people or organizations are convinced into releasing or misusing systems in a sense? And finally, the options, the knowledge retrieval architecture, you've got different options for how you instantiate that, and that will give different performance levels and different levels of trust. So that's another. I do think a couple of points came up in some of the discussions that I thought were interesting, and that is I typed into the UNDP the same question that you asked Benjamin for the top 5, and that's the top 3 to see if they were ordered in a sense, and it gave a slightly different version, all sensible, but not exactly the same because the question was slightly different. So I think we need to think about that, different answers for different people, again, about that confidence. There is the possibility to have some of these guardrails. You can have machine unlearning now, so that while you tell an LLM, don't do this, it can unlearn. And CMU, Carnegie Mellon University, earlier this year, did some of that on ChatGPT, so that it gave some answers that it was actually supposed to guard against. So these are some of the big challenges that we see.
Carsten, thank you so much. We ran out of time, but this is a fascinating topic, fascinating from research, fascinating from development. I'm really a big fan to see that we could put this thing to use, but most importantly, to put it in a fair manner, in a safe manner, and an equitable manner. So thank you once again for being with us, for these insightful comments. We want to continue now the episode by moving into another major way in which AI is affecting identity, and that's in the biometric algorithms. As you know, ID systems need biometrics, and therefore, for the most part, they need biometrics. And therefore, let's see how biometrics have been affected by AI. Just I will give you an aside. Back 30 years ago, when I was involved in the development of the early biometric algorithms, we did have neural networks and powerful learning algorithms, just like the backpropagation that we see today, etc. However, we lacked data and computational resources to train these networks. So consequently, we set aside AI and concentrated instead on analytical approaches for feature extraction and building mathematical models for face, finger, and iris biometrics. These models proved highly effective and fueled the identification revolution for 2 decades. They also helped us explain what features are used in biometric identification. something that neural networks cannot do. They don't explain to us the answer, they just give us the answer. Nonetheless, as time passed, analytical models that started the whole field reached their accuracy limits. And unfortunately, during the same period, there has been a seismic shift in the availability of biometric data for training, and the cloud emerged as an inexhaustible computational resource. As a result, about a decade ago, the academic and industrial research communities restarted exploring neural networks and machine learning for biometric algorithms. Their progress over the last decade is amazing. And to help us appreciate this major development, we're pleased to have one of the scientists who contributed to this progress. Please join me in welcoming Dr. Stephane Gentric. He's the chief AI scientist at IDEMIA. Stephane will deliver a very informative presentation. And hopefully, if we have a little bit of time at the end, we will be able to have some questions. Otherwise, Stephane will provide the answers online following the conclusion of his segment. Stephane, thank you for being with us. Welcome, and the stage is yours.
Thank you, Joseph, for presenting me. I will share my screen, my presentation. Oh, no. Do you
Not yet.
Not yet. Why? Yes.
Yes.
Okay. Yes, I will try to talk about artificial intelligence, how it impacts biometric algorithm. So I will shortly try to explain how biometric recognition work. I will talk about performances, fairness, generative AI, how it impacts biometrics, the new threats that are coming, so deepfake and morphing, and then I will conclude on, yes, if we have time, answer a few questions. So the story starts in the 50s, when the first algorithm tried to mimic the way a human tried to solve different tasks. Then we have machine learning, which is a subpart of artificial intelligence. At that stage, people try to tune or learn some of the parameters directly on data. And now we have deep learning, which is a new name for neural networks that do not take knowledge from the human, but directly take knowledge from the data. So the traditional approach, the one you talk about just before, and that works during more than 20 years, they just try to, in a first stage, to extract a lot of discriminative information directly in the image. So by passing multiple filters or to computing some gradient, then you end up with a bunch of different values. And then in a second stage, you try to reduce and to merge all those values in order to build a discriminative representation of the image. So we have all those methods that have worked during really many years. So a well-engineered traditional method give accurate results on well-aligned image, but in fact it was really not robust, for example, for pose, for handling occlusion, or stuff like this. So now we use deep learning. This means neural networks. So a neural network, this is just a big network of neurons. So neurons, this is simply a simple function that multiply all the input by parameters and then apply a nonlinear function. Then with this neuron, you build different neural network with different layers, so simple network or deep neural network. Currently at IDEMIA, most of the biometric algorithms use between 100 or thousands until thousands of different layers. So we have very big neural networks. And then we have for complex neural networks that are showing up. So attention network or transformer are new generation or architecture of neurons that improve also the complexity of the representation you can learn into your data. So we are talking about neural network, so neural network, but also learning. So how do we learn? So in this simple example, I will try to explain how we learn a simple classifier. So here, for example, if we want to classify these images as a car, we will propagate directly the pixel into the neural network. That, in fact, is a simple function that takes this image and that produces an output. And at the beginning of the process, when we try to learn this neural network, all the different parameters, so all the link between the different neurons are initialized randomly. And as they are initialized randomly at the beginning of the training process, all the value that will be output will be complete random value. But we don't learn only from the image, we also have a label. And then here we know that we want to have 1 for the first entry and 0 for the other, because we have the label that this is a car. Then we describe a loss function. Here, this is a simple error between the output on the label. And then we will slightly, with this image, modify all the parameters into the neural network in order to reduce this error. And then after that, we will do that millions of times with millions of images. And at the end, this neural network will learn that this image is a car. And even with images that look like car and that are not in the training data set, the neural network will succeed to accurately classify the images. So this is the way this is trained. So in fact, I don't explain at all that this is a car to the algorithm. I just give him a lot of images on label, and then he learns how to recognize the image. So in the biometric workflow, there is a lot of tasks. All of those different tasks are achieved by neural network that learn on specific tasks. So it starts with detection. So for face recognition, when you have multiple faces or objects in the image, the first neural network will try to find the position of all the objects. Then we have the alignment. Once we have found a face, we will precisely try to align these faces by using neural network that will predict the precise position of the different feature points of the face. Then we will ask a different neural network to compute a lot of qualities. So those qualities will allow that will be very useful in the acquisition process to select the best image, but also in an ID system to discard image that don't have the needed quality for producing the ID document. And then we have the coding process, so the part where we build a biometric template directly from the image. So for this last one, the way it is learned, so it is simply learned exactly like for the car in a classification manner. So we have huge data set with multiple image per ID, and each of the different class, the different class is an ID. And then we will try to, during the learning process, to classify all the different ID. Multiple image from a given person will end up in the same class. So once we have learned this, and it takes weeks of GPU to train this kind of models, we will throw out all the classification part, and we will keep also the part of the network that will produce a feature vector, and then the matching part, so the part where we compare two different templates to tell if they belong to the same identity. It's a simple Euclidean distance or a scalar product between the two feature vectors. So this is why in large ID system, the coding part, so all the smart part are in the coding part. So where the neural network project the image, transform the image directly in a template, and then for matching in a large scale system, the matching is very fast because we simply compute distance between the search template and all the templates that are in the gallery. It is more or less the same kind of ID that are used in fingerprint recognition. And fingerprint recognition, now algorithm doesn't try to, we do not explain to the algorithm how to find a minutia on what is the direction and how it works. Now, neural networks can directly predict from the image the minutia position and the minutia orientation. So what does it bring us in terms of performances? Biometric is a technology where performance can be precisely measured, and is really a difference between a lot of other techniques. We can measure performances on the algorithm. On the US NIST has been the benchmark organization for biometric testing for more than 20 years now. They evaluate software on sequestered data. So this is one of the plots they produce. So this plot can be directly found on the NIST website, and it shows the evolution of performance of face recognition for the past 5 years. And here, this is the false not match rate, in fact, the accuracy, and this is in a log scale. And we can see that during the past year, even after the deep learning revolution, the algorithms are still improving a lot. And this allow really new application to show up with face recognition. In terms of absolute value, now face recognition is able to search for someone in a 12 million dataset. Here we have performances of IDEMIA. It is tested on different datasets. So on the biggest dataset with 12 million of images, now the accuracy is far above 99% of performances. And one thing that was not possible before deep learning, and even not possible a few years ago, is that now we are able to find directly with a profile image, for 90 degrees profile image, we are able to find with a very high level of accuracy to search and to find people in a gallery where all the images are all frontal. So in fingerprint, we see also the same kind of revolution. Here in red, you have techniques that use only minutiae to find all the different minutiae on the fingerprint and try to compare them. And then with the deep learning revolution, a new category of algorithms show up that work more or less like face recognition. So directly take the image and input and then produce a template that can be directly compared with another template with a scalar product. And we see the huge improvement that deep learning has also bring to fingerprint recognition. Fairness. Fairness is now, so as the performances of biometry now reach a point that in most of the application with cooperative people on good quality images, we don't have any problem in terms of accuracy. Now the community focus on fairness, and we talked in the previous talk on fairness also, and it's become really a major topic for deployment of face recognition system. So it involves regulation, metric, and evaluation. Regarding regulation, the European Commission asked the ISO SC37 to define a standard on remote biometric identification system. And of course, IDEMIA is involved in the process, and IDEMIA is even a co-editor on this ISO standard to help to define how to assess the compliance of deployment with the regulation. The second point is the metric. Fairness, it's not so easy to measure if an algorithm is fair or not. And then we want to assess the fairness and then compare multiple algorithms and to see which one is more fair than another. So NIST start to think on this. And we try to find what is the best metric to do that. And IDEMIA was really active in NIST discussion and also with ISO committee discussion to set up the relevant metrics to assess fairness and then to assess fairness of algorithms. And then evaluation. So a few years ago, the NIST published a first report on impact on demographic effect on biometric recognition. And from 2022 now, for all face recognition algorithms that are submitted to the NIST also publish performance in terms of fairness alongside to the raw performances of the algorithm. So this is the kind of table that you can find on the NIST website. So you have the algorithm, you have the raw accuracy, so the false non-match rate for different accuracy, and you have those two metrics, so which are the max over the mean. So you have different groups, and then you compute the maximum error rate, and you divide by the mean of all the error rate you have on the other group, and then you have the Gini coefficient that try to measure the disparity in terms of error rate between the different groups. As you can see, so the IDEMIA submit an algorithm last year, and this algorithm is still among all the algorithms that were submitted at the NIST, the one with that is more fair, but it has the more similar performances among all the different groups. Here you have the more fair algorithm, and here you have also some competitors that have also very good accuracy on this data set, but you can see, so those are two Chinese companies, and you can see that in terms of fairness, they are very far, and the algorithms are really biased. So by working on this, we hope that that we can have a positive impact on the industry by pushing the competition between developers in order to produce more fair algorithm, and also we will help users to be sure that they will deploy a fair algorithm. Regarding fairness also, so the NIST report excellent results for IDEMIA, but also the DHS, the Department of Homeland Security, perform a benchmark every year on acquisition system. So here you have the different acquisition system, and here you have the matching system, and then people go in through different acquisition system for the different provider. The goal was to provide the best images, and after that all the matching engine try to compare the different best image that have been produced by the acquisition system. So here you can see that not only IDEMIA had the best acquisition system, but also that the performance between the different groups, so between male and female, and between darker skin and lighter skin, are the same, and there is no significant difference between the different groups. One important thing here is when we talk about fairness, the acquisition system is really important, because in the acquisition system, to produce the best image, you need to have algorithm that assess the quality, that control the camera, the gain control, or those parameters of the camera that will allow to have a good quality image, whatever the skin tone and whatever the gender of the people in front of the system. So generative AI. So generative AI is a subpart of deep learning. In generative AI, we talk about the large language model previously. Another part here is the use of synthetic images. And yes, now it is possible to generate fake images directly with a neural network. So the way we do that is with a generative adversarial network. The way it works, or the way it is trained, is simply with two different neural networks. One neural network that is a discriminator, that exactly like the neural network that try to make the difference between car and other class of object, it will try to discriminate between a real image and fake images. So during the learning process, we will provide him a lot of fake images and a lot of real images, and he will just try to learn to make the difference. And at the same time, we have a generator, so another neural network that will, from a random value, a vector of random value, will try to produce an image. So at the beginning of the learning process, this neural network do not know how to produce a real image, so it will produce some garbage. So then it will be very easy for the discriminator to make the difference between real image and this garbage. But during the learning process, the generator will try to fool the discriminator, and then will produce more realistic images. And at the end, it will produce images that the discriminator will not be able to differentiate. And then we will have this kind of images. So here, all those images are synthetic, synthetic images. So those are not real images. And then as the input vector is in a continuous space, we can continuously move in this feature space and look at the image that have been built. So this technique exists for a very long time now, and you can find on the internet a lot of applications that are able to produce this kind of images. For our community, having one image per identity is not the final goal. In fact, at IDEMIA, we had different needs. We want to have huge variability in terms of identity. And also, we want to produce multiple images per synthetic identity if we want to use them in biometric system. So for that, we have a multiple researcher that have produced some work, and we publish all the work. And now, in fact, by splitting the random value into two parts, one part that is dedicated to the ID, and another part that is dedicated to intra-class variation, we are able to produce multiple synthetic images of the same fake identity. So in fact, this was needed for one customer asked us to provide this kind of images to test his system, and then we build more than 300 million of synthetic identity for this purpose. And here you have for each identity, we have here plot 5 different images of this fake identity. So yes, AI comes and then bring a lot of improvement in terms of accuracy and a lot of improvement in terms of building synthetic images to test the system, but also it brings some new threats. So the two threats I want to talk about today are deepfake. So deepfake, this is simply synthetically animated a real face. So here, this is work from an academic team, and then they are able to synthetically animate those three only from one image to animate those things. So in fact, this topic is a threat for remote enrollment application, and it's a subpart, in fact, of the threat that fall into the liveness detection part. So to be protected against this kind of threat, there is two different aspects. The first one is the cybersecurity part. In the system, we develop algorithm that will protect against injection attack in the system. And also, this kind of threat fall into the general presentation attack detection algorithm, where we want to detect all the different presentation attacks coming from the simple photo to the more 3D fake model that will be put in front of the sensor, trying to fool live enrollment. Another threat is morphing. So morphing, as we can build synthetic images, we can also control the way we build synthetic images. In fact, here there is multiple tools that are now available on the internet that efficiently merge two different images of two different people. And the thread with this kind of images, that is a merging of those two, is that these images match, so it's very close to those two images. And this is a threat. If this kind of images end up in an ID document or a passport, those two people can use this passport to go into a biometric system. So the defense, so the first one is to control the document acquisition, and if possible, try not to accept images that come directly from user. The second defense is to use a recent and accurate face recognition algorithm with a high threshold. So these images is close to those two, but it's also somewhere in the middle. So if you higher the threshold, this image will not match against those two images. It will match with a lower probability. And then now we develop morphing detection algorithm. So by using a recent morphing detection algorithm, you can detect easy this kind of image. On my last slide, I have a conclusion. So yes, AI and deep learning have boosted improvement in the biometric algorithm field. Face recognition works now with a very high level of accuracy, with more than 99.8% on a dataset with 12 million of identity. The great improvement over the recent year leads to, so all those improvements in terms of accuracy, they lead to new use cases. So now we can find a photo, a person using a photo that is more than 10 years old. We can find a person with a profile images. We can acquire good image photo while the people is moving. For fingerprint is allowed now to have acquisition system directly with a smartphone. With iris, now we have systems that are able to acquire with good image quality iris at distance. And for all the different biometric modality, now we are able to build synthetic data set in order to test the system. So yeah, it brings also new topic. So fairness, that will solve at IDEMIA in most of use cases. Morphing, that is really a new thread that is coming. Regulation and the impact on AI deployment and data management. So AI is creating huge new opportunity to advance identification technology, but we need to continuously invest into this field. And finally, IDEMIA will continue to maintain a large experience in-house research team and will continue to lead the NIST benchmark on performance test.
Okay, thank you. Thank you, Stephane, for this fascinating presentation. There are a lot of new elements here. Fairness metric by NIST, in particular, is something for the community to pay attention to, so that we can know when an algorithm has a fairness problem, which is a key in the development agenda. The great set of new use cases that you've identified, the importance of biometrics in the remote enrollment context and how we have to have countermeasures to ensure that's the case. Stephane, we don't have time for questions and answers, but I'm sure people know how to contact you. And if anybody wants to have a question, please put it online, and then maybe Stephane could answer it privately.
Yes, for sure.
Okay, but thank you once again for this fascinating presentation. It looks like you guys are having fun in the lab, so it's wonderful to see. Thank you very much.
Bye.
Okay, we're now ready to move to the next part of this segment, another fascinating segment, where we will meet a biometric hero who has been working over the last 20 years on how to detect and stop spoofing attacks on biometric systems. She has battled many biometric evils and has, for the most part, won her battles. Let us now see how she intends to battle the AI villains. So please join me in welcoming Professor Stephane Schuckers. Stephane, thank you once again for being with us. So perhaps you can start by characterizing for our audience the nature of the threat that AI poses to biometric systems. We've seen how wonderful AI has done improving biometric systems, but the question is the nature of the threat pragmatically, realistically, and compare it to the threat vectors that you have battled in the past years.
Thank you very much, and thank you for having me. I'm really happy to be here. You can see I am also having fun in my lab.
It looks like it.
Yes, I brought some of my friends to show you what we're up to. You know, this is something we've been researching, as you pointed out, for a number of years, how to detect spoof attacks. So these are physical attacks that are presented to the biometric system and sometimes called presentation attacks or PAs. And then to detect them, we call it presentation attack detection or liveness detection. So we've been working on this, and as you're probably aware, if you use biometrics in any use case, there are a number of different systems that reject spoof attacks at the sensor itself. Those liveness detection solutions help with that. So now what, right? So now we've just spent the last hour or so, talking about AI and generative AI and deep fakes, and great introduction by our last speaker on what that threat vector looks like. And so where do we go from here? Can we only detect physical attacks like I'm showing in my picture, or is there more that we can do? And so that's really what my focus has been on, and we can discuss today sort of how these same tools as well as new tools can help with presentation or with deep fake attacks.
Excellent. Actually, that's precisely the point I wanted to do. Sort of, what do you use in your defense arsenal to kind of repel these attacks? Maybe you can walk us through some of the things that you practically use.
Yes, great question. So, the first thing to think about is security. So always you want to be preventing the possibility of what we call an injection attack or a man-in-the-middle attack. This is basically a digital interception past the sensor. So you have a camera, right? But you sort of bypass the camera and pretend there's a real camera in place. And that's where you become vulnerable to things like deep fakes, because you are now not able to trust the actual camera. And so how do you secure that? Of course, we use our typical security mechanisms that we always want to use. And I sort of think of it like a Swiss cheese model. This is the first layer of the Swiss cheese that you want to have in place is good practices in terms of IT security. But then there's the second layer of the Swiss cheese, that relates to if they were able to, one way or another, take over the camera with something like a virtual camera, and then with that virtual camera inject a deep fake. Now you need another layer of protection if they bypass the first. And that's also, similar to presentation attack detection, but maybe more generalized, to this particular threat. So what we want to do is something we call liveness detection or challenge response. And I can kind of dig into that, but it's kind of, I don't like to talk for too long in a row. So.
Well, actually, listening to you, I got the sense that we're talking about the same principles of medieval defense. When you had a walled city, you had the moats, you had the walls, you had the tower guards. So you've got these multi-layers. I guess security principles have continued to be the same principles that we've done throughout history, right? Multi-layer.
Absolutely. And I think what's interesting, from a biometric point of view or from a deep learning point of view, is that the attackers are using AI. We also need to use AI as one of those defenses, and so the way to do that, is, challenge response. What does that mean? That means, creating a relationship between you and the camera, so the physical world and the digital world, right? Such that it's very hard for the deep fake to replicate that, right? And so there are many examples of that, simple examples in terms of just even an interaction between either voluntary or involuntary. That's what we call challenge response, like, shining different colors of lights, looking at sort of specular reflections on the face as I turn my head and I can see the sun coming in through the window. These kinds of things help, to reject a deep fake, because the deep fake can't model it on the fly.
But I can imagine also, if we move into a multimodal world, that a deepfake that works in one modality, when challenged by requiring another modality, might not be able to produce it. I mean, what's your opinion about that?
Right, and that's, and when you say multimodal, I would say that's a biometric thing, but also, a digital thing, like multi-factor, right? So I think many of the kinds of solutions when we talk about, say, remote identity proofing, right? That is very much a multi-factor activity, right? That incorporates biometric to connect that physical, biological, as well as ensuring their liveness, but also has other factors like the document itself and authenticating or verifying the document is legitimate to the extent you can.
I mean, this is the application that is most interesting to our community, which is how do we build remote onboarding so that we can allow governments to basically issue digital identities without having to bring the entire population in, which costs money and time and requires bureaus and offices for them to go to. So do you feel that we have, as a community, what it takes to create a reliable remote onboarding process without having to succumb to that massive vulnerability from deepfakes and other injections? Do you think we have the technology today?
Yes, we do have the technology, but we do have to go into it eyes wide open, right? To understand what the threats are. And I think that's been great that you've had this session today, to really dig into those threats, so, it has to do with, the ability of the solution, to recognize the threats, and the threats can come in many forms. We're talking about the deep fake threat. So that's the human, threat to the human aspect of the comparison between the biometric captured at the time and the biometric in the document, or in the biometric that might be stored in some previous identity interaction. So we have to understand those threats, as well as threats, to, the actual document side of the equation. And of course, another threat relates to morphing, that was brought up in the last talk. And so, from the point of view of the submission of an identity, a photograph, that's where, ensuring that capture incorporates and is from that legitimate source, possibly with a live enrollment, right? Various means. It's sort of that you're resting everything else on top of it. So you want to make sure that live enrollment, is from a legitimate individual and not a morphed photo.
And it's interesting you say that, because now many countries in Europe that I'm aware of require you, when you submit a passport photo or a residency request card photo, you actually cannot submit any photo you want. You have to go to the photoshops that are licensed by the Ministry of Interior, and they have a secure connection, and actually the image is digitally signed to be authenticated and to be legitimate, and is sent immediately. You don't send anything. So do you think that's an effective approach to explore within the development context, to have basically, if you want to do remote enrollment, you have to submit the images from a secure source?
Yeah, I think if that's your very first point of contact between the individual and the authority, I think that is best practice. If you have already, a face on record and then want to build upon it, through a re-enrollment or a reissuance, then I think that's when you could potentially turn to a remote identity solution that still appropriately, looks for, spoofing activities as well as deep fake injection. So basically does matching against your authoritative source, as well as a liveness check to ensure that there's not an attack.
Now, we keep getting this question, how do project managers or government organizations know if they bought a product or a solution that will do the job? I mean, is there some sort of testing certification that they should be looking for spoof resiliency and things like that?
Yes, we've been working for a long time in this field. There are ISO standards on how to do testing around spoof detection. And with that, there are certification bodies that can look at and follow those ISO standards to look at the robustness. I've been working with the FIDO Alliance in recent years, and that alliance is related to authentication, but also has a new component related to the kind of solutions we're talking about, remote identity verification solutions. So, querying a document, taking a photo, a selfie, as well as liveness. And so we have a certification program around those solutions, and also a testing framework that you can look at. It's all public.
So do you mind giving a reference to that certification process? What is it called, and where do people need to go to find it?
I can drop a link in the chat. It's the FIDO Alliance.
Right.
And, if you're using biometric technology like passkey, you might have heard of this for authentication on mobile devices, and then eventually to the relying party. That's what their focus is in terms of specifications. But as I said, now because of account recovery and remote onboarding being so important to our ecosystem, they have certifications around that, and I will drop the link in.
Great. But this was a very recent program. When was it launched, the certification?
So the biometric for authentication certification has been a few years old. The new program for the selfie match against the document is not even quite posted yet. So it will be on the same page that I've linked, but it should be there and available in December. But then there's a document authenticity part, which is basically detecting if you take a photo or query a document, is it a legitimate document? That has been available since early this year. So yes, this part is very new. So
it's fair to say that yes, there has been new tools to attack, to spoof biometrics, but your colleagues, your researchers in the field have been building countermeasures, and more importantly, it's not just theoretical. We've got certification programs that if a government wants to make sure the product they're procuring is subject to certification, therefore they can have more confidence in the fact that it's not just the vendor saying that, yes, they are resilient against spoof attacks, but they can actually rely on the level of certification that they've received. I could imagine, Stephanie, that this is not a static field, that this is going to keep you going and busy for many years to come, I imagine. I mean, what's your roadmap looking like?
Yeah, great question. We talked about deep fakes, and that technology, the way we think about it, is very similar to the way we think about these kind of attacks. These masks are fairly sophisticated, maybe the bobblehead a little less sophisticated. The same thing we think about with injection attacks. How easy is it for someone to step up, go to the web, Google, find the code and create a deep fake of themselves, right? And it's gotten to be very, very easy. And there's some very simple tools you can use. And so when we think about our threat vectors, we're trying always to keep ahead to say, okay, how well are we detecting at the sort of tools available to everybody, as well as the tools that are available to the more sophisticated actors. So, the fun continues in my lab.
Actually, let me ask you about your friends behind you. Are these real people?
Yeah, they're all real people. So for example, this is me.
That's you.
So I create a 3D model. I'm sorry about the glare. I don't know if you can tell. And then also, this is my bobblehead, which, I know is a little bit small, but still, when you kind of put it, the camera has no idea of the depth.
It has no idea what the size.
Yeah, so It has no idea that it's small, because so if I just put it here, you
exactly
can understand that the camera might foresee it as a potential spoof.
Wow, fascinating. I think you're definitely having fun, but good news is that fun is benefiting our community and helping keep us safe. And so thank you again, Stephanie. We look forward to continuing to track your progress. Okay.
Thank you.
Thank you. These are wonderful insights. Let us now move on to another seasoned veteran of the biometric community, Francis Zelazny, who is the CEO of Anonybit and who has been in the biometrics industry for over 20 years and is now one of the foremost experts in identity fraud prevention. Francis, thanks for being with us as always. Practically speaking, what is your take on the threat that AI poses to trust in biometric-based digital identity systems?
Yeah, so first of all, Joseph, thank you for having me. It's always a pleasure, and really enjoyed all the comments until now. But I think Stephane did a good job with laying the foundations with the basic risks from a biometric perspective around deepfakes, synthetics, and morphing. I think that another real threat to understand is the data management aspect of this. So these models are generally based on people putting data in, and so then you have a lot of personal information and a lot of sensitive information that could be cobbled together in much of the same way that is already being done by attackers to thwart identity systems today. But this, of course, puts it on another level.
So, I mean, you're talking about spear. You're talking about spear phishing attacks and sort of getting sophisticated, knowing a lot more information about people and having AI craft an entry or a way to sort of phish, get people to fall on for that. I mean, is that what you're talking about?
So there's two aspects. One is the spear phishing to get people to trick you into handing over credentials and coming across as very legitimate. Like I know things about you, I have access to things about you. And so I call with a concern or I email with a concern, and now you think that I'm a legitimate person because this information is out there, and these AI tools can craft very sophisticated and believable messages, emails that are repeated, not just one time. I think that's one, that's one major risk. And then another is combining the information that is out there to create what Stephane was talking about in terms of synthetics. So he talked about it more from the biometric perspective, but I'm talking about it from a identity, more of a holistic identity creation. So it's not just the face, but also other information that you can put together that will bypass some of the current KYC checks, for example.
Right. Actually, for many years now, you have actually been advocating that when we look at fraud, you can't look at it uniquely from the lens of identity. So elaborate on how should we look at this, and how does AI aggravate the identity fraud landscape if we don't do it right?
Yes, I think first, I think it's important to understand how fraudsters operate and what is the core, what are the signals that can be captured in fraud. And then we can look at what are the signals that are captured in identity, and then think about how to put them together. So on the fraud side, there are very clear signals. They tend to be devices, they tend to be locations, they tend to be velocity, things that behavior that are considered attributes aligned with expert fraudsters, expert attackers, you've already used AI to create patterns, to understand the patterns and to identify whether and how certain interactions are fake versus real. Fraudsters also operate under the 80-20 rule. So they pretty much are, trying to do things at scale. It's very rare that you find things that you've never really seen before. And so these AI models are just kind of learning all the time, what kind of malware is being used, what kind of patterns around location. I mean, when I was in payments, there were very, very, very clear patterns around zip codes where gangs and fraudsters were operating, and it was amazing. So if you could identify that critical mass, you can very quickly cut down on fraud. Of course, fraudsters are also and attackers are also advancing, and they use the primary tool today in their arsenal is really stolen personal information. It's really easy, given the way personal data is stored today in centralized honeypots and the lack of defenses, to constantly create more and more, what we were saying before, more and more databases that are connected, information that is available to circumvent the controls that we have. This is anywhere from stolen passwords. And we all know, despite the warnings and despite the pleading, how many people continue to use the same passwords over and over and over again, or variations thereof. How many people use password as their password?
Yeah.
So it's really difficult to get past passwords because of all of the legacy applications that we have. So attackers are using that primarily to get in and then steal information and then put that information on the dark web. And the dark web is a whole economy.
Right.
Right.
Yeah. And it's well-oiled machine. I mean, they don't specifically target one person, they target large numbers so that it makes sense to scale. But, you know, there's another issue that I wanted to discuss with you, which had to do with the fact that many of these systems, when you were in fraud business, the authentication system, the fraud signal risk system, and maybe the location system and things like that, sometimes they're not integrated, they're siloed. I mean, don't you think that that's one of the problems that could be eliminated?
It's a huge problem. So back to the databases, if you really look at why fraud is happening, so it really boils down to three things. One, personal data stored in these centralized honeypots that are impossible to protect. Number two, we allow the use of this stolen data for authentication. And number three, our systems, both from the onboarding, account origination, through authentication and account recovery, are not connected. And the technologies that are used to combat the threats in the different channels and across the different aspects of the identity landscape are also not connected.
And I heard you say once that one of the biggest areas for fraudsters is the account recovery area. That's a big vulnerability, not in the authentication. How does that work, and how do we prevent it from becoming a bigger problem?
So one of the biggest surprises that people don't really either they don't understand or are not aware is that, especially in the private sector, when you do digital onboarding or identity verification, 99.9% of the time, that data is discarded because of privacy reasons. Enterprises don't want to store it because they're afraid of a data breach. See, all these things keep on coming back to how data is protected and privacy. And so that data gets discarded, and that causes the siloed approach to how you do authentication. So FIDO and passkeys are great in terms of having the cryptographic key from a device talk to a server, but in fact, if you don't know who's behind the device because the authentication or the enrollment of the device is separated from the onboarding or account origination, you've created a gap that an attacker will exploit. Similarly, in account recovery, if you're calling into a help desk or a call center, and the only tool you have at your disposal is personal information like your name, your identification number, again, that's available. So in order to really combat the problem, we need to thread together or unify or integrate, whatever word you want to use, the different aspects of the identity lifecycle. And quite frankly, biometrics is really the only common thread for a person across the board.
Okay, and hopefully you're not going to collect it and save it in a centralized honeypot. You will find ways to actually have that data distributed somewhere. I want to ask you, give us the top 5 things that governments or big enterprises that want to manage identity should do to make their digital identity more fraud resilient or resistant.
Yeah, so just practically speaking, it starts with eliminating centralized honeypots of personal data where you just left off. I think that we are in a new era around, so just as there's been enormous advancements in AI, there's been enormous advancements around a class of technologies called privacy enhancing technologies. These are things like zero knowledge proofs and multi-party computation. There are other techniques as well.
Okay, so number 1, no honeypots, no centralized honeypots.
Use
Number 2,
privacy enhancing technologies.
okay.
Number 2, unify the user journey. Ensure that you have a consistent, persistent biometric from digital onboarding to authentication and account recovery.
Okay.
Number 3, this has been spoken before, use liveness detection to ensure the realness of the biometric that is presented, and there are technologies that are getting better and better and better in this area.
Number 4.
Number 4, injection detection. So Dr. Schuckers talked about this a little bit from the biometric perspective, but I just want to iterate here that injection detection is nothing new to the fraud world. And so we just need to borrow those techniques into the biometric space to make sure that a session hasn't been compromised, even if the liveness passes. So that's number 4. And then number 5 is combining all of the mechanisms from the fraud world, dynamic fraud prevention, risk detection, with the identity detection. And we cannot forget that user experience and user interaction is also really, really important. So combining this will help with the fraud and the threats, but it will also help to enhance accuracy and maintain a good user experience.
Francis, fantastic. Those 5 recommendations are really, really right on point. So we appreciate your insights, appreciate you being with us, and we look forward to seeing you once again in other contexts. So thank you. Okay, so we're going to continue. We're going to move on to the 3rd and final segment of this episode. AI in Africa and the ethical dimension. In this segment, we will contextualize our dialogue on AI to Africa, and we'll pursue it within the broader development agenda, including an examination of the ethical risks. As I said earlier, this topic is evolving rapidly, and many multilateral organizations are convening forums as we speak to try to begin to frame the issues and explore a global approach. So I caution you, we are not there yet, but what we have already is a cause for major concern, but also some optimism. The 2 sides of a very big AI coin. We will start with a scene-setting presentation by Dr. Melissa Omino and Dr. Angeline Wairegi from the CIPIT Center in Kenya. Please join me in welcoming Dr. Omino and Dr. Wairegi, who will successively go through their presentation. Thank you for being with us. The stage is yours.
Thank you so much, and I hope I'm audible. Please let me know if I'm not. Excellent. So I'll just go ahead and share my screen. Also presenting with me is Dr. Melissa Omino. I don't know if she wants to say a quick hello. Excellent.
Hello, everyone.
All right, so our presentation today really focuses on what AI, specifically Gen AI, means for Africa. So Dr. Omino and I represent an organization called the Center for Intellectual Property Information Technology Law. It's a bit of a mouthful. CIPIT is the acronym. We're based here in Nairobi, Kenya. We're housed under Strathmore University, and part of our mandate as an independent research institution is to really look at AI, but really look at it from the perspective of Africa, use an African lens to really critically analyze the narratives, the development, and the impacts, both real and possible, future impacts that this technology has. So I won't dwell for long on what generative AI, the past speakers have already laid a wonderful foundation on it. But I would just like to point out two important things to think about when you are thinking about AI in general and generative AI specific when we're talking about Africa and its use in Africa, is that its innate characteristic is both its superpower and the obstacle that it presents for us. So the power that generative AI has is its ability to synthesize and analyze large quantities of data and generate output. And this can be any number of output. It can be textual, it can be visual, it can be audio. So it can be any type of language that we program it to analyze and give us output in. But this is the superpower, but this is also the problem, because to do this accurately and efficiently, it needs large quantities of data, right? So where is it getting this data from? What type of data is it using? And the output is directly related to the data that it uses. So if there's any bias, as one of the speakers presented earlier, if there's any bias in that data set, if there's any bias innate to that algorithm, then the output that it generates will reflect that. So what does this really mean globally and for Africa? Well, the global impact for generative AI is already being felt. I think everyone on all corners of the earth has heard about ChatGPT, and they're either really enthusiastic about it, about its potential, or they're really worried about its potential, right? So if you think about ChatGPT in schools, it's being lauded as both a potential solution to a lot of problems like student-teacher ratios crisis that many nations face, access to quality education. So it's being lauded as a potential solution to that. But then it's also bringing up issues of plagiarism. And what does it mean now that students have this tool where they can just input a prompt or a parameter and it just generates the entire solution for them? What does that mean in terms of learning? So the impact of ChatGPT, is already being felt worldwide. But we're also seeing generative AI being used in commercial enterprises. It's a big tool for marketers. Coca-Cola had this advertising campaign called Masterpiece a while ago, where the advertisers use generative AI to link historical art pieces with live action films to come up with an ad that was really, really effective. It's also being used in medicine. It's being used in some medical training programs. I believe Duke or Yale has classes around the power of AI in medicine. It's being used in drug discovery. So we're already seeing the global impacts of generative AI. I should say at this point that a lot of what we're seeing in terms of utilization and development tends to be not in the global south. It tends to be in the EU or the UK or the US. So we in the global south currently primarily are still consumers of these tools, primarily consumers. We're seeing some development happening, but not as much as we're seeing in other regions. So that leads me to my first crucial point. Since we are a baby step behind other regions, I would say, I think it's really important for us to take a critical lens to what we're seeing in terms of the narrative around generative AI or just AI in general, right? We really need to understand are these promises, do they align with our on-the-ground realities? And if they do, then what do we really need, given those realities, what we need to make sure that we are able to access, to leverage these tools, right? And if they don't align, then what's the disparity, and how can we make sure that we're able to leverage these tools to our benefit and to have solutions for our unique problems? So it's really essential that we don't buy wholesale into the silver bullet myth that surrounds AI and surrounds generative AI to some extent. It's really important that we take a critical lens to that narrative and really see what that means for us as Africans in terms of development of these tools, deployment of these tools, adoption of these tools, and impact, and even governance of these tools. So it's a very delicate balance, making sure that, one, we are ensuring that we have the maximum potential that we can get from these AI tools, but we're also ensuring that we have guardrails in place. That means that the risks are mitigated or eliminated, ideally, but definitely at least mitigated. So that's the balance that we have to strike here. So for this discussion, Dr. Omino and I are going to take you through three things. We're going to talk about the potential opportunities that these tools can have for the continent. This is a very broad topic, so we'll only touch on a few things, but we'll also talk about the risks and the challenges that we have. One, the challenges in development, for example, challenges in governance, but also the risks that these tools pose if we decide to adopt them. And then lastly, if we do decide that we must play in this particular field, or if the world decides for us that we must play in this particular field, how can we make sure that we are best placed to actually have a role, a substantive role in AI, not only in AI adoption or consumption, but actually in the development and in discourse and governance around AI? So to begin with, I'll just touch on what are the particular opportunities that AI or generative AI has for the continent. So the first one I want to talk about is commerce, particularly in the biggest revenue generator that we still have on the continent, which is agriculture. So agricultural activities are our primary revenue generator still. And these tools offer large potentials to solve a lot of the problems that we have around agriculture. So a lot of the continent is plagued with food insecurity, meaning that the amount of food that we produce is not sufficient for consumption, let alone for commerce. So there is potential to utilize these tools to, one, make sure that crop yields are maximized, that waste is reduced, that the land is managed appropriately, and that climate change factors are mitigated. So the one way that we can do this is by using them to predict weather patterns. So AI tools can be used to analyze historical data to actually show us what's the most likely possible weather scenario that we can have in XYZ number of years. And then if we know that, we can plan accordingly, right? This could help us minimize food waste, increase crop yields, because we know what's coming, then we can plan for it. We can also use these tools to detect soil health, to look at crop disease, crop cycles, and see what are the best ways to maximize yields based off of that information. And we can also look at it to simulate or to model, climate change occurrences, whether these are extreme weather patterns or something else. And this is already being done. So like climate change modeling or climate modeling is something that's actually occurring. So we can use that to help our agricultural activities here on the continent. We can also use it for just general commercial activities. So in terms of logistics and supply, we can use Gen AI tools to predict demand. There's an e-commerce tool, there's an e-commerce platform, called Jumia that is available here in Kenya, Nigeria, I think parts of West Africa, parts of North Africa. I don't know all of the countries where it's available, but they actually utilize Gen AI tools to predict consumer demand, and that cuts down on waste. We can use it to enhance customer interaction. We can use it to train entrepreneurs on digital skills that they'll need to grow their businesses or sustain their businesses. So there's a lot of potential for Gen AI tools on the commercial side in Africa. Education is another big opportunity. So ChatGPT raised or caused quite the fracas when it entered into the world. And a big part of this was concern around its utilization in education. So a lot of what we've really seen is the negative, at least the proposed negative impacts of that. I mentioned one, which is plagiarism. But also, people can use it and that would decrease learning opportunities instead of increasing them. But I think the opposite is also true. We can leverage Gen AI tools in areas where access to education or access to quality education or access to education is hard to come by, right? These tools can be used to teach students how to write. They can be used to teach people how to critically analyze text. They can be used to shift teachers' workload. So instead of having them really use so much time on the minutiae of teaching, things like grading or lesson plan, we can have these tools do that. And then that would free up the teachers' times to work more with the students. So I think the big two in terms of Gen AI's impact in education on the continent, or possible impact, is one, it would allow for personalized instruction. So in areas where people don't have access to instructors or the student-teacher ratio is quite high, then you can have these tools customized learning, which would better lesson outcomes or learning outcomes. It would also help with administrative tasks, right? So if it frees up administrative tasks, then that energy, that time can be put back into the students. So I think there's a big opportunity for the use of Gen AI in education on the continent. Another area where we have a significant lack on the continent is the area of healthcare. So if you're in the urban cities in Africa, you're usually all right in terms of accessing a medical facility, depending on where you fall on that social economic strata. But if you're in more remote areas, more rural areas, then lack to quality healthcare is a real big concern. But generative AI tools, they pose this opportunity to make access to healthcare easy and accessible to everyone. We're already seeing some of these tools being used in places like the US. So they just had a study where they programmed an AI platform to take pictures of children and use those pictures to diagnose Kawasaki disease. So just with a smartphone, it's possible that we can be able to use smartphones enabled with AI technology as diagnostic tools. We can also use them to better healthcare outcomes and better patient treatment. So this has already started. We're seeing small signs of this. There's an organization called Hafone AI that has partnered with two medical companies here in Kenya and in Uganda to integrate generative AI into oncology treatments, to improve healthcare outcomes in there, and also the level of patient care that's being offered. So Gen AI tools offer great opportunities as a stopgap measure in areas where healthcare is either inaccessible or just not there at all. And then lastly, in sustainable development, and this is such a broad field, but I'd just like to focus on two things. The first is renewable energy, and the second is urban development. So in most areas in Africa, we see quite a significant rural to urban migration. We see significant rural to urban migration happening. And the consequence of this, or the result of this, is we have urban areas that just do not keep up with the number of people that are now currently residing in them. But with generative AI tools, we would be able to model this particular rural to urban migration flow, model the number of people that we would expect to make that movement, and create cities that are not only workable, but are healthy, sustainable, and green. So that's a great opportunity that's offered by these tools. So we would be able to allocate resources for the construction, since we know what the demand would be. We'd be able to predict the infrastructure that's required. And I think that would really ease a lot of the strain that we're seeing in the urban centers in Africa. The second is with renewable energy, or with energy just in general. So as I said, we're based in Kenya, and it's a lot better than it was when I was young in the 90s. But we still have occasional blackouts. Power loss is sort of the norm, and I think it's sort of the norm in most cities, most countries on the continent. But with generative AI, there is an opportunity there to leverage it to actually use it to make renewable energy sources the primary energy source on the continent, and make sure that people have access to reliable and consistent and sustainable energy. And we're already seeing these tools being used in other places. There's a company called Bertelsen in the States that's actually using generative AI to predict demand for green energy in a couple of cities in that country. So it's not science fiction, it's something that can be done. So I think that's a great opportunity that we have there. And I don't want to take up too much of my counterpart's time, so I will just stop there and hand it over to Dr. Omino.
Thank you so much, Angeline. And I'm really honored to be here to talk about generative AI in Africa in a broader sense. And it's just unfortunate that I'll be talking about the challenges and the risks, but challenges and risks do occur everywhere. So I'd like to speak about 6 major challenges that Africa faces with regard to generative AI. And one of the most common challenges is misinformation and disinformation. And this often happens in the realm of elections and in marketing and advertising. The importance of elections anywhere, but especially in Africa, cannot be understated. And these are life or death matters on the continent. And the use of such tools, such as generative AI, especially on social media platforms to spread misinformation and disinformation, is not only a possible threat, but one that has already been experienced on the continent. Odanga Madung, a Mozilla fellow and data scientist, has explained this in his research focusing on Kenya and Nigeria. And CIPIT has also found evidence of micro-targeting on platforms, on social media platforms, that is, similar to what Odanga has found. And there's evidence of use of generative AI tools to spread the misinformation. There has also been concerns about the potential and actual use of deepfakes, as we have heard earlier today. And there has been a story, I think about a month or so ago, about a deepfake that was used to impersonate, allegedly, an African authority figure at the AU. And this created quite an uproar about the misinformation and disinformation aspects in terms of generative AI. So the main issue in question here is if we can trust this type of emerging technology, and how do we get there? The second aspect that I'd like us to discuss is the question about the accuracy of results. Now, the narrative is that artificial intelligence, because the word intelligent is used there, can do no wrong and potentially can make no mistakes. So when we think about this, those of us who are millennials remember the common adage when we talked about computer science, garbage in, garbage out. That doesn't seem to really be the case in terms of popular culture when you talk about generative AI. And especially so in the African context, it's seen as the messiah, as something that will come to solve problems. And there's not really questions around the accuracy of results. However, we do know that the accuracy of AI depends on accurate and diverse training data. So the more accurate and diverse the training data is, the more accurate and diverse the generated output will be. In the African context, there is a gap between sufficient training data with African context-specific data, as well as LLMs that run it. So what does this mean? It means that the accuracy of the results drops due to this in our context. Furthermore, there are common aspects within several jurisdictions, as we've heard earlier, of hallucination by the algorithms. And this means the models being putting out output confidently, but it's actually an invention of incorrect answers. And the capacity within the African context to be able to tell that hallucination is happening, and also to be able to understand or sift through the large language model data to figure out where the issue is, might be lacking. So the accuracy of results is definitely the second major problem that I would like to highlight, and I'm glad that that has also come up previously. Third is the question of bias. The algorithms may contain inherent biases in their source code, as they are coded or developed by persons, meaning human beings, who in themselves may have existing biases. There's also the possibility of biases learned from the training data, and especially where that data does not adequately represent African cultures and perspectives, leading to questions around fairness. Dr. Chinasa Okolo has carried out research on prompt text to image bias when using the prompt African worker, and the image results which showed up were completely biased towards a Western understanding or view of what an African worker would look like. This is an example of a lack of context within the African framework to be able to give accurate results, which I've mentioned earlier, but also showing the bias of those people who coded the source code or modeled the algorithms. Therefore, in the African context, we would need to also factor in the further stratification of society that could lead to more bias. What do I mean? The biases around tribes, the biases around gender, age, and even class that would show up and would therefore need to be balanced or redressed in the use of generative AI. This definitely pushes the narrative that CIPIT is definitely behind, that we need African AI developers to code and prepare algorithms for use to solve African problems in the African context. They would be able to redress or balance the bias around tribes, gender, age, and class, because they are within that context and understand it. There's also the very big issue of copyright and intellectual property. And this shows up in several aspects around generative AI and AI broadly. When we talk about algorithms and source code, these definitely feature as intellectual property assets. There was a conversation earlier about whether these algorithms or models are open source. And there's also a conversation currently happening on the continent about the data sets that these algorithms are trained on, but also the data that is being collected for the large the LLMs. And we do know that a lot of data is required. So if AI, and specifically generative AI, thrives on data and algorithms, and both of these fall within the purview of IP, it means that African AI developers have to consider intellectual property issues, laws, regulations that would affect their ability to generate Gen AI tools. So most African developers tend to use open models and algorithms and modify them for purpose. However, they are limited on the use of these models by the licenses that attach to them. We heard earlier that you could have an open model that is not completely open, or you could have an open model that has certain terms and conditions that are attached to it. So this affects the ability of African AI developers to generate algorithms that are fit for purpose. So with regard to training data, the developers are finding a gap in the availability of data in the African context. If you think about natural language processing and African languages in particular, and you think about ChatGPT obtained a large part of its model, of its database, from trolling or mining the internet. On the internet, there's not a lot of information in African languages. So it would not be able to sufficiently train its algorithm to be able to meet the demand or the threshold for a particular African language. I think Kiswahili, or what others from outside the East African region call Swahili, is the largest language that we have as a database. And this is what the African AI developers are grappling with. They are encountering this lack of data available to train their data sets. And they're also encountering IP obstacles where that data is available. So for example, let's say a media house has translated its articles into an African language, then copyright would attach onto that translated version. And there is a lack of resources to be able to pay for the licenses that they would need to text mine that data. So they are now trying to develop their own LLMs, and to do that, their resources are usually funded by different funding organizations. And they are happy to go ahead and build the corpus. So for example, this Ken corpus that's being built that would include a large number of natural African languages within the Kenyan region. But you would find that part of the parameters of that funding would be on copyright related to that data that is being collected, and that would need that data to be open. So the African developers and their companies are facing questions of sustainability and competition with those who have more resources than they do, and the ability to utilize these new data sets better than the African developers are, purely from a point of having financial resources, computing capability, and manpower to do so. So these are the critical questions that we need to ask about copyright and IP within the African context in order for us to solve African problems.
Sorry, Dr. Omino, we have just
Yes.
about 1 minute left for your section.
Thank you.
Thank you.
Thank you for that. So let me move on to my next slide, which is on data privacy and security risks, which we've heard also from previous conversations in the presentations today. And it is clear that data is not a natural resource. So I'm firmly against the adage that data is the new oil. I think that data exists and is obtained from communities or various groupings of data owners, including from governments who are custodians of data of their citizens. So in the African context, there are major strides made to address data protection from the lens of privacy. We have a number or a plethora of data privacy laws that have been implemented. We also have regulations and establishments of data protection offices. So the fact that this data will be utilized by generative AI means that within the design of the models or the algorithms, privacy has to be a consideration, especially if you think about prompt data, which is sensitive personal data, as we've heard earlier. That standard of protection needs to be higher. And in the African context, even higher for vulnerable and marginalized groups, such as women, children, and the stateless.
Dr. Amino, we ran out of time. Could you please wrap up quickly?
Yes. So wrapping up, I think what we need to do, how does Africa participate in generative AI? I think infrastructure is a major point to consider when formulating a future that involves generative AI. And this means thinking about the resources that were mentioned by Angeline earlier, the availability of data centers, as well as the digital public infrastructure that would help the utilization of Gen AI tools. Thank you.
Thank you. Thank you very much. Unfortunately, we ran out of time. You raised a very important point, which is the lack of data sets which are used. So AI systems are hungry for data, but there's something else that they're hungry for, which is computational resources. Operator, put up a slide very quickly. I want to show a slide that will show you why I'm concerned about the situation and then inequitable situation that we're seeing in Africa. So operator, put up that slide, please. So what this shows you, it shows you the computational, the chart illustrates the distribution of the computational resources that are available across the continents. As you can see, the global north commands an overwhelming 95% of the world's intensive computational capabilities, while Africa possesses a mere 0.2%. I invite you to contemplate the potential repercussions of this glaring imbalance over the next decade should it remain unaddressed. Africa cannot afford just to be a consumer of AI. It has to become a developer of AI, but it can't unless this issue is addressed. Okay, with that, I'd like to invite Govind Shivkumar, Director of Responsible Technology of Midyar Network, to join me to continue the conversation, sort of put the points on the I's. Govind, thank you once again for being with us. You are in a position, being in your job and in the way where you are, to see what's happening in AI globally around the world. And I think you would agree with me, there is a new arms race going on in the world. So give us an idea, what is at stake in this new arms race?
Thank you, Dr. Atick, and thank you for giving me an opportunity to speak before this wonderful audience. And good morning, good afternoon, and good evening to all. Dr. Atick, I think I would probably compare this to the evolution of the printing press, the Industrial Revolution, and most recently, the digital revolution. We historically have thought about some of these technological influences and developments as a global north problem, but are any of these revolutions do not impact the global south population, which has a significantly larger quantity of population, which is young, which is dynamic, and which is going to perhaps be quite influential over the next 50 years, right? So one of the things that we think about at ON is how to, of course, think about paradigms. And this technological paradigm is very similar to what Dr. Carlota Perez has spoken about, saying every technological revolution is followed by a financial revolution. It impacts paradigms in 4 separate ways. One is, how should we think about laws? How should we think about regulatory frameworks? How should we think about corporate structure, governance, infrastructure? And how should we think about, most importantly, public expectations? So this revolution is upon us. The question is how we respond. And we need more agency to influence this technology. As generative AI, as our participants said, is being integrated to every aspect of our society. So that's what it's at stake. The future of our civilization, the future of our economy, the future of our political reality.
So in other words, Africa cannot afford to sit this one out.
Absolutely not.
Okay. And so basically, if we looked at it as an inevitability that we must, in the development context, we must allow an equitable participation. What are the barriers to entry for a nation or a region into the AI revolution, as you called it?
Indeed. I think one of the biggest barriers is creation of these large language models. right? Which are quite expensive. I think in order for you to create a new large language model, you need upwards of $300 million, and as chips that someone has mentioned, and I'll go into it
Repeat again the
deeply.
price, the cost. Sorry, repeat the cost again.
$300 million at least, and as chips
at least.
become more and more expensive and rare, we are estimating for us to create a new large language model in the next few years from scratch could go up to upwards of $1 billion.
$1 billion.
Yes.
Actually,
so that requires, yeah, go ahead.
I mean, it's not just the cost of the equipment. I mean, think about the electricity. I mean, one of these machines is 30 megawatts. Think about what 30 megawatts running for a year would be. This is about $50 to $60 million of electricity. If we put this in Rwanda, for example, as an example,
Yes.
I mean, it's not just $1 billion in the equipment and acquiring it and the technical skills, but it's also the electricity that's going to be needed. I mean, it's mind-boggling, the scale.
It's electricity. It's even if you have the infrastructure, it's water resources. It's access to chips in this new geopolitical game, which we'll go into a little bit more deeper, and the talent and the data that you need access, right? And to keep these systems running, which is to be contextualized. Fortunately, there are some ideas that we can deploy to get there faster and get there relatively in an inexpensive manner, which we'll discuss downstream. But those are the barriers to entry. I see 3 barriers to entry. The cost of creating a new LLM, which you can sort of diversify by using some smaller models and by using open source models. The second is access to compute, which is extremely critical. Through cloud and through local contextual resources, the chips themselves, creating chips clusters and getting access to chips is quite difficult, with 2 companies having a duopoly. ASML in Netherlands is the only company in the world which manufactures these machines. And TSMC is the only company in the world which produces these chips. And NVIDIA is the only country that has access to the technology behind it, right? And none of them are in the global south, technically. So they're all in the global north. So the supply chains are harder to crack, both from a logistical standpoint and a geopolitical standpoint. And the third is data, right? A lot of the data on which these models are trained are all broadly open data available on the net, but they are largely contextualized to an increasingly global north audience and population. So we need contextualized data, we need talent, we need compute, and we need resources. So those are the barriers.
Now, give us some hope. I mean, what ideas can we explore that you have seen work in other similar contexts that we can explore within Africa and the global south?
Yeah, I'll probably start off with some broader ideas which have worked in the other regions, right? Especially these are albeit global north ideas. So I'm sitting in New York and DC, where the government is quite concerned about AI safety, in addition to access to resources and chips. They've recently, you've seen a lot of policy dialogues emerge at the highest level. There was a new executive order by the President Biden's office. There was office of the Vice President came out with a statement. The G7 in Hiroshima has released a statement. The Bletchley group in the UKI summit has released a statement. Similarly, at the African level, at the African continent, this has to be the level of the Prime Minister, the President at the highest level, right? We need to think about technology and policy issues. First, make it an important policy agenda, important technological leap agenda for the highest offices. Second, there are some examples, particularly for compute, such as setting up, one idea is similar to an NSF, the National Science Foundation Access Program, and CalCompute in California, giving access to compute to universities. Africa has significant technical universities. So how can we bring a similar continent-wide initiative and paradigm to get access to these compute resources, particularly for startups, academic researchers, and small and business medium enterprises who otherwise won't get access to this innovation, right? And innovation happens in many of these countries at a more decentralized level. Third is, I think we have to really critically think about cloud. Cloud is probably the most important factor because cloud scalability ensures that AI applications can handle workloads from small experimentation to large deployment, and without incurring infrastructure costs. So the stakeholders we mentioned, broader public, academia, researchers, startups, small companies in Africa, they cannot cobble up and convene capital to invest billions of dollars on their own. The state and the government have to step in, have relationships with other countries at a geopolitical level who have access to these chips. Because Africa is inevitably in the next few years going to be an important consumer and an enterprise market, not just for software, but also for consumer goods. It's the youngest continent on the planet. The next few years belong to the African continent. So how can we enter into geopolitical relationships which are quid pro quo with some of these countries and companies who have access to these compute resources and provide them to technical universities and people who need them to create these innovative attributes? These are some ideas. Create an Africa cloud, similar to NSF Access. Create an Africa compute access program. Find geopolitical partners, alignments globally in the Middle East, in Asia, and in North America who see Africa as an important partner, both as a trade partner as well as a geopolitical partner. And finally, invest in talent.
Invest in talent. I'm seeing the lip service that the global North is paying to the voice of Africa, and I'll be very frank and honest. I'm seeing I think it's the global North, especially at the level of the African Union, African Commission, OECD, realize that a lot of their safety regulations and ethical considerations are not taking into account the African voice. And in order to rectify this, some steps are being taken. For example, the OECD is holding an Africa-specific policy forum in March with the African Union. It will be held in Europe, unfortunately. And it will be basically about sort of the African voice into the ethical dimension, but it's not addressing what I see as the fundamental issue, which is the lack of access of Africa to the foundational resources that are going to be needed for them to participate. They will remain consumers. The continent will remain a consumer unless we figure out some of the ideas that you've talked about. I'm intrigued by the Pan-African cloud. How far are we from that? Most of the cloud efforts are fragmented in Africa. Maybe you know better.
I think most of the cloud efforts, apart from sort of these three large companies who provide majority of the cloud support globally, Amazon, Google, and Microsoft, most of the other efforts tend to be decentralized or fragmented. I think Europe wanted to have a more cohesive cloud unisive support system or create a European cloud. I think we are not far away from a technological standpoint in Africa. I think possibly one of the considerations is how can we bring about some political, economic, and social harmonization to at least have a sandbox. It doesn't take a lot of effort to create an African cloud initiative and a sandbox to say we need to create this so that we can, one, provide competition to existing players, but also have more agency over data, have agency over innovation, have agency over access to other markets, right? You surmised it very well, saying Africa is being looked upon as a consumer. So what will it take for it to be a very, very advanced producer? Almost, there's this initiative of making Wakanda real. So what would it take for it to be real?
Exactly.
A way would be to create a homegrown cloud initiative so that, one, you can prove your technological superiority. You can prove that the union stands together when it comes to challenges, for political and social challenges. And the third is, once you have a common framework and a common market, like we have seen in Europe with the Brussels effect, we will have something like the Africa effect, where technology, when cobbled together by all the nations together and have a common initiative, you send a much more stronger message, right, as a common union. So I feel that we are not far away from a technological standpoint. If we see the strategic importance of this particular initiative, it's more of a political and economic paradigm shift.
Right, and I wanna create the sort of the wake up call within the development agenda. In fact, this is reminding me of what we saw 12, 13 years ago. 12, 13 years ago, basically, I was heavily involved in the India Aadhaar and sort of realized that digital identity was a pillar of development. But at that time, the development community was not involved. They were like thinking of building bridges and building roads and highways and infrastructure like that. And so we started the ID4D movement. It started with my colleagues at the World Bank, and we convinced the senior management that that's what needs to happen. And I'm now seeing a need for something like that, is to basically explain to them that a pillar for development could be AI, and should not be looked at only from the ethical dimension, which we'll address very quickly in a moment, but it should be looked at from the fact that it has an economic developmental factor, and that the development community needs to allocate its resources to help alleviate the gaps that we see. I mean, you come from a development actor, but a very special development actor. So how do you view the role of the development community in enabling the catch-up to happen in Africa?
Indeed, I think you made a pertinent point about the analogical reference to digital identity and payments and infrastructure that is being currently created to create a whole host of new products, services, and applications, which the African continent is now a leader in, right? Like digital payments, for instance, in many ways. We still have some way to go, but the adoption has led to creation of future-looking
leapfrog.
Future-looking infrastructure, also future-looking geographies and future-looking economies, which are not residing in the present. So I would probably think about what is necessary in 2030 if AI is all around us. It is being embedded into every single product service, including digital payments, including your insurances being decided by this large language model, your healthcare, and some of the applications that my colleagues at Snippet mentioned. For that, you need to lay the groundwork today. Suddenly, you can't play at the application layer and start creating these products and services, because then if you don't have the roads very well robust, it's going to be very difficult for you to invent cars. So how can we start thinking more cohesively about the future and future-proofing some of these developments through making investments today in infrastructure, in policy, in talent, and most importantly, data, right? Like a lot of the context to applications, to use cases will come from country-specific, Africa-specific data.
Right.
So how do you create robust governance mechanisms? You spoke about ethics, which we'll talk about a little later. How do you create specialized use cases so that you can take advantage of the upside of this revolution, and at the same time put in safeguards, right? Like through data protection mechanisms and stuff like that. But you have to start thinking today if you want to be even a player in this race in the next 5 years.
And there's one additional dimension that I kind of hinted to, which is the impact on social safety nets. And I mean, I think of safety nets as things that we need when there are shocks, like natural disasters, wars, and general things that push people down into the edge of people who are on the edge of poverty, down into the abyss of poverty. If somebody is listening to this and they are from this social protection, social safety nets, how real is the risk that the AI revolution could end up pushing a lot of people over the edge? And what can we do to alleviate the situation, obviously?
I think in many cases, we have to acknowledge that some of these jobs will be replaced, like how it has happened historically, right?
Right.
Travel is a great industry. Some parts of healthcare is a great example of how these jobs have been, I wouldn't say replaced, but they need to be augmented by technology. So one of the ways to think about social safety nets is we have historically spoken about different paradigms like, UBIs, universal beneficial income, and so on and so forth. But investing in talent, right, at an early stage, I also think, to be honest, AI is going to actually provide a lot more leverage to people who really need to learn a skill very quickly. Take, for example, writing in a different language or communicating with someone in a different language. So one of the things we've been thinking about is, hey, AI is going to replace through automation a lot of call center workers, but it's also going to provide perhaps a real-time translation mechanism that have precluded many countries in Africa from taking part in this because English is not their natural language.
Not their language,
or like participating in global markets where you can do this real time. So if someone from social safety net is listening, I would probably say, hey, we need to make this, we need to leverage AI so that people can access social safety mechanisms. A lot of time, I think access and knowledge of these schemes is severely lacking. Understanding the technology and providing mechanisms for population to use it very safely and simply, just like we've done with payments, and providing, I think, broader benefits. For instance, if I want to know if there are 100 schemes under which I qualify, how do I figure out simple things like filling up a form? Now they can be done by voice, from voice to text synthesizer. So I would sort of flip the question and say, how can development professionals use this technology to make sure resources are used well and you reach your beneficiaries or your constituents and your stakeholders the most efficient and effective manner? Because ultimately our game is to improve the service of impact.
Yeah. I think, Govind, we could go on and on. Unfortunately, we've ran out of time. I look forward very much to seeing you again. Thank you for these insights. I enjoyed our discussion. Ladies and gentlemen, this brings our episode to an end. I hope you found the discussions useful and inspiring. And we look forward to continuing this journey together as AI continues to bring changes and to impact our development efforts. We will see you on the next episode where we are going to cover digital identity and health. So that's another vast topic that's touching on our lives and touching on everybody, not just in the Global South. So please be with us at that moment, and we look forward to seeing you then. Thank you.